Hello, good morning. Uh, so let us start information technology rapid revision session. So basically, we'll start with a small introduction. Okay, my name is Sandeep Kumar. I'm a BTech in computer science engineering, and also I'm a qualified ACS. And I completed my LLB. So I'm working in one of the pharma industry. So this is my, I have 2 years experience in software and other, years, okay, in the industry. So this is my brief introduction. Now let us start introduction to computers. Okay. So let me share the screen. Now, you already know we have 5 chapters, okay, but I will not, do in the form of, okay, so let us start this. Okay. So, we have 5 chapters, okay, mainly if you see chapter 1 deals with, two aspects, business process management and we have other part called as mapping systems. In mapping systems also we have different types of mapping systems like flow charts, data flow diagrams, etc. Okay, so basically business process management chapter 1 is regarding how exactly a process can be designed. Okay, the basic concept of business process management is how exactly a process is defined and how do we connect one process to another process. Okay, that is regarding chapter 1. Now, chapter 2 is about the basics of information technology, like different types of devices, what is the introduction to cloud computing, what do you mean by business process automation introduction, etc. And we have 2 more topics in chapter 2, that is SDLC, and we have layers of information systems. These 2 topics are very, very important in chapter 2. Okay. So after that, we have chapter 3. Chapter 3 deals with the telecommunication networks. Now, why do we require networks? Here, telecommunication networks also, if you see this particular chapter, you have 3 parts. Okay, first part is about telecommunication network, second part is about network security, and third part is about internet, intranet, and extranet. Okay, so these are the 3 parts you have in chapter 3. And after that, you have chapter 4. Chapter 4 is about information systems. Now, this particular chapter is specifically about what exactly is an information system and different types of information systems and advanced softwares also, like we have artificial intelligence, business intelligence softwares, etc. Okay, so this chapter basically is about softwares. Okay, so different types of softwares or different types of information systems. Okay, and last chapter is about business process automation through application software. Now, this particular chapter is about, we have 3 topics here. One is emerging technologies, and the second part is business process automation, and third part is controls. Okay. So today, okay, we'll start with chapter 3 because chapter 3 is a very, very important and it's a little bit of lengthy, but it's very, very important. Okay. So let us start with chapter 3. Before we start with chapter 3, we need a small introduction to the information technology that we'll see, and then we'll move to chapter 3. After that, we'll move to chapter 4, and we'll move to chapter 5, chapter 2, and chapter 1. Okay, so I maybe, because of the time constraint, okay, I may be teaching few of the topics, okay, not the entire, subject, but the most important and very, very critical topics which I'll be teaching you. Okay, so let us start with introduction. So if you see this particular introduction, the basic words, okay, in information technology is very, very important. Okay, so even at the time of presenting the answers in the exam, okay, the words makes the difference. Okay, So the words are very, very important and prominent. You need to write these particular words at an, at a situation you need to write the right word. That's it. Okay. So words are very, very important in information technology. Okay. Now let us start with computer definition. So if you see computer, so what do you mean by computer? Computer is nothing but an electronic device. Okay, so it is nothing but an electronic device. What exactly it will do? It will take the input, okay, and it will process that particular input and produces an output. Okay, so what do you mean by computer? What exactly, why do we require a computer? A computer is nothing but an electronic device which is required, okay, which takes the data or which takes the data from the user or from another system, okay, and converts or process that particular data and produces an output. So this is a small definition of a computer. Okay, now we have a concept called as computer system. So we have here the concept called as computer system. Now what do you mean by computer system? Computer system is nothing but, okay, different parts or different components of computer. Okay, so basically when you call a system as a computer system, it should consist of 4 parts. Okay, first part is hardware, second part is software, third part is user or people, and fourth part is data. Okay, so these are the 4 parts or 4 components you would be requiring. Okay, so what is the first part? First part is hardware. What is the second part? Second part is software. What is the third part? Third part is user or people. And what is the last part? Last part is data. Okay, so these are the 4 components you would be requiring to call a particular system as a computer system. Okay, so as if you see a human body, okay, we have certain components. Okay, so most important or critical components. Without that particular components, can I call a particular system as a human system? No. Okay, the same way, even if you see a computer system consists of certain parts which are very, very, very important, okay, in order to call a system as a computer system. So what are those 4 parts? Okay, first part is called as hardware. So what do you mean by hardware? Any physical component of a computer is called as hardware. Okay, so if you take any component of a computer, physical component, okay, which you can touch, okay, is called as a computer hardware. Okay, so what do you mean by a computer system? Computer system consists of 4 important components. First one is called as hardware. What do you mean by hardware? Any physical component of a computer is called as hardware. Okay, so what do you mean by any physical component? Can I call keyboard as a hardware? Yes. Okay, because you can touch. Can I call monitor as an hardware? Yes. Okay, you can call monitor also as a hardware. Okay, now second one is software. So what exactly is a software? Software consists of set of electronic instructions. Okay, so what exactly a software is? A software consists of set of electronic instructions. Okay, so why do we require a software? You require a software to make a hardware run. Okay, so why do you require a software? Software is nothing but an electronic instruction. These instructions are required to make a particular hardware run. For example, okay, now if at all you want to print a document, okay, you open that particular document and you will say Control P. Okay, so what exactly is a Control P? Control P is nothing but an instruction. Okay, instruction saying that, okay, now printer, you start printing this particular document. Okay, so this is, okay, nothing but an electronic instruction to activate a printer. The same way, what exactly a software consists of? A software consists of a set of electronic instructions. Now, why do we require a set of electronic instructions? To make the hardware run and to perform an activity. Okay, we require this particular software. And how many types of softwares we have? We have 2 types of softwares. First one is called as, we have 2 types of softwares. First one is called as system software. Second is called as application software. So how many types of softwares we have, sir? We have 2 types of softwares. First one is called as system software. Second is called as application software. So what do you mean by system software? Any software which is used for the purpose of managing and controlling internal components of a computer is called as system software. Okay, so what do you mean by system software? Any software which is used for the purpose of managing and controlling internal components of a computer is called as a system software. Okay, So what do you mean by internal components of a computer? Like it is nothing but internal hardware units, okay, like main memory, secondary memory, etc. Okay, this particular software will manage and control the internal components. Okay. Now, what is an example for system software? Windows, iOS, Android, etc. So second type of software is nothing but application software. Now, who will use this particular application software? This application software will be used by user. Okay, that type of software is called as application software. Okay, so what do you mean by software? Software is nothing but okay, it consists of set of electronic instructions. Okay, so how many types of softwares we have? We have two types of softwares. First one is called as system software. Second is called as application software. So what do you mean by system software? A software which is used by a computer is called as a system software. What do you mean by application software? A software which is used by the user is called as an application software. So you need to have a basic idea of this particular classification. Okay, if a system uses for the purpose of managing it and managing its internal components called as hardware, no, that type of software is called as a system software. If a software is used by the user to perform a user's task, then it is called as an application software. Okay, so examples for system software: Windows, iOS, Android, etc. Okay, so what do you mean by application software? Any software, like let us say, okay, you take Tally is an application software. Okay, you take any gaming software, it's an application software. Okay, so next component is user or people. So who is a user or person? It is nothing but user or people. It's nothing but a person who operates a computer is called as people. Okay, so can a computer run on its own? No, a computer cannot run on its own. Okay, a computer should be operated by a person. Okay, so that is called as people. Okay, next one is called as data. So what do you mean by data? Data is nothing but raw facts is called as data. Okay, so how a computer stores the data? A computer stores the data in a binary format. Okay, so what do you mean by binary format? Any combination of zeros and ones is called as binary format. Okay, you take any hardware of what do you mean by binary format? Okay, any combination of zeros and ones is called as binary format. Now, okay, what exactly data includes? Data includes character, number, images, videos, etc. Okay, so you take all this particular thing, the character. Okay, any alphabet is a character. Okay, so how does a computer stores this particular character? A computer stores this character in the form of zeros and ones. Okay, how does a number store? Number also will store in the form of zeros and ones. Images also will be stored in zeros and ones. Videos also will be stored in zeros and ones. Okay, so this is about components or okay, critical parts of computer system. So what are the critical parts of computer system? First one is hardware. Second one is software, third one is user or people, fourth one is data. So what do you mean by hardware? Any physical component of a computer is called as hardware. What do you mean by software? Software is nothing but it consists of set of electronic instructions. How many types of softwares we have? Two types, system software and application software. And third one is user or people, and fourth one is data. So this is about computer system. But we have to understand, in order to understand this particular information technology, so we need to understand, okay, certain parts, okay, of hardware. Okay, we'll not be dealing with all the components. Okay, we'll be dealing with only few hardware resources. Okay, now let us start with okay, hardware resources. What do you mean by hardware? Hardware is nothing but any physical components of a computer. I can call it as an hardware. Okay, so we'll not be studying okay, all the hardware resources. We have few hardware resources which are very important for our understanding of the subject. So those components will study. Okay, so if you see first one, okay, first one is nothing but a processor. So what do you mean by processor? Processor is nothing but a component which runs an instruction. Okay, so instruction will be provided either by a user or a software, because what exactly a software is? A software is nothing but okay, it consists of set of electronic instructions. Okay, now what exactly a processor will do? Processor will execute an instruction. Okay, for example, okay, now let us say if I say stand up. Okay, so what exactly I'm doing? Okay, I'm giving an instruction. Okay, so what exactly will happen? Okay, you'll hear that particular instruction through your ear and it will go to the brain. Okay, now what exactly brain will do? Brain will execute that instruction and an action will be performed. Okay, the same way here also a processor will take an instruction and it will execute an instruction to perform an action. Okay, now where exactly the processor resides? The processor resides on an electronic circuitry board called as motherboard. Okay, we'll be having an electronic circuitry board, okay, called as motherboard. On this particular motherboard, all the components will be connected. Okay, now it uses a material called as silicon. Okay, so what exactly is the material it uses? It uses a material called as silicon. Okay, so what do you mean by silicon? Silicon is nothing but 100% pure sand. Okay, so if you take sand and if you purify that particular sand to the extent of 100%, now that particular thing is called as, okay, silicon. Okay, now this particular processor is also called as CPU or brain of computer. Okay, it is also called as CPU or brain of computer. Okay, so this is about processor. So what do you mean by processor? Processor is nothing but an hardware unit, okay, which runs an instructions. Okay, so it uses, where exactly it resides on motherboard. And what is the material it uses? It uses a material called as silicon. What do you mean by silicon? 100% pure sand is called as silicon. Okay, and this particular processor is called as CPU, or it is also called as brain of a computer. Okay, so you need to have a idea of these particular words, because in every page of information technology which we study, these words will appear. Okay, if you don't have the clarity of these particular words, it's a little difficult to understand. Okay, so second hardware resource will study about main memory. Now this main memory is also called as, okay, primary memory or memory. Okay, now why do we require this particular memory? Generally, memory is required for the purpose of storing the data. However, this particular main memory will store the data only temporarily. Okay, that means, okay, if the power is there, it holds the data. If power goes out, okay, it wipes the data. Okay, so it is only a temporary storage. Okay, so if at all you take this particular main memory, this main memory is also called as volatile devices. Okay, VOLATILE, volatile devices. So what do you mean by volatility? Volatility is nothing but if any device stores the data temporarily, then that particular device is called as volatile devices. Okay, so main memory is called as volatile device. And we need to understand one particular rule which is very, very important. Okay, whenever you are using any software, it has to be loaded into main memory first. Okay, so whenever you are using any software, it has to be loaded into main memory first. Okay, what do you mean by loading a software into main memory? For example, okay, let us take Temple Run. Okay, now once you install Temple Run, once you click on that particular Temple Run, okay, so what happens? Okay, once you click on the Temple Run, it takes certain time for the purpose of starting. Okay, so what happens in that particular duration? The entire software will be loaded into main memory. Then the processor will start executing that particular instructions. Okay, so you take any software. Okay, when I say any software, it can be a system software or it can be an application software. Even system software, when you, okay, like let us assume, okay, when you have an desktop. Okay, when you switch on the desktop, what exactly you see? Okay, on the screen it says loading. Okay, so what exactly it will load? It will load operating system into main memory. Okay, so let you take any software, let it be an system software, let it be an application software. First, the software has to be loaded into main memory. Then only the processor will start executing the instructions. Okay, so that is this particular rule is very, very important. Okay, you take any software, first it has to be loaded into main memory. Next one is called as input-output devices. So what do you mean by input device? Input device is nothing but, okay, input devices are required for the purpose of interacting with the system. For example, keyboard. Okay, so without keyboard and mouse, can we interact with the system? It is not possible. Okay, so input devices are required for the purpose of interacting with the system. What do you mean by output device? Output devices are required for the purpose of presenting the result. Okay, so for example, monitor. Okay, so it shows the data. Okay, or it displays the data. Okay, so that is called as an output device. Okay, so input devices are required for the purpose of interacting with the computer. Why do we require output devices? Output devices are required to display or present the result. Okay, and last component is secondary memory. Now, what do you mean by secondary memory? Secondary memory is nothing but secondary memory, or it is also called as, okay, hard disk drive, HDD. Okay, hard disk drive, or it is called as storage. Okay, and if you see your entire study material, so if you see the entire study material, they will use a word called as storage. Okay, so what do you mean by storage? Always remember, storage means secondary memory. Now, why do we require this particular storage? Storage is required for the purpose of, again, storing the data However, what is the characteristic? It stores the data permanently. Okay. So if at all you see main memory stores the data temporarily, whereas if you see secondary memory stores the data permanently. Okay. So if a device stores the data permanently, those devices are called as non-volatile devices. Okay. So if a device stores the data temporarily, then the device is called as volatile. If a device stores the data permanently, then that particular device is called as a non-volatile device. Whenever you install any software, where exactly the software will be installed, whether it will be installed in processor, whether it will be installed in main memory, whether it will be installed in input output devices, or whether it will be installed in secondary memory. Where exactly, when you are installing any software on your mobile or on your desktop or on your laptop, in which component the hardware will be installed, whether it will be installed in processor, whether it will be installed in main memory, whether it will be installed in input output devices or secondary memory. Always any software, it has to be installed in the secondary memory only. It should not be installed in the main memory. What happens if at all it is installed in the main memory? It will be stored only temporarily. That means whenever you switch off and switch on your cell phone or laptop, whatever installation you have done, it has to be removed. Now whether it is happening that way? No. That is the reason whenever you are installing any software, it has to be installed only in the secondary memory. So this is the introduction which you require for the purpose of understanding the other concept. So this exactly is the introduction. So we studied the basic definition of a computer. So after that, we studied, what is a computer system? A computer system consists of 4 components: hardware, software, user, people, or data. And after that, we studied about different hardware resources. So what are different hardware resources we have? We have processor, we have main memory, we have input output devices, and we have secondary memory. So processor is required for the purpose of executing an instruction. Main memory is required to store the data temporarily. Input output devices are required for the purpose of interacting with the computer and for the purpose of displaying the data. And secondary memory is required for the purpose of storing the data permanently. And which devices will use, the devices which stores the data permanently is called as non-volatile devices. So this is the introduction which we require. Now, let us move to our portion. So let us start with chapter 3. So let us start with chapter 3. So we will not be learning as as per the series of study material. We'll be learning in a different way, because without understanding chapter 3, we cannot able to understand chapter 4, or other chapters. So chapter 3 is a very, very important chapter. Now let us start with telecommunication networks. So what do you mean by telecommunication networks? And why do we require telecommunication networks? Before we go into this particular telecommunication networks, we need to understand what do you mean by communication. So communication is nothing but if 2 people are talking, so that is called as communication. So what do you mean by telecommunication? Telecommunication is nothing but if 2 devices are exchanging the data or transmitting the data from one computer to another computer, then it is called as telecommunication. So why do we require telecommunication networks? Telecommunication networks are required for the purpose of transmitting the data from one device to another device. The basic objective of networks is to transmit the data from one device to another device. For example, if at all you take WhatsApp, so WhatsApp, what exactly we are doing? We are transmitting the data from one point to another point. Now, which network we are using? So don't tell Idea, Vodafone. So we are using a network called as internet for the purpose of transmitting the data from one point to another point. WhatsApp is just an application, through which we communicate. But what exactly is transmitting the data from one point to another point? It is always telecommunication network. So which network we are using in WhatsApp? We are using an internet for the purpose of transmitting the data from one point to another point. So the basic reason, why do we require telecommunication networks? For the purpose of transmitting the data from one point to another point. Now let us see a small definition of a telecommunication network. So what do you mean by telecommunication network? Telecommunication network is nothing but it consists of set of computers and terminal devices. Okay, so what exactly is a telecommunication network? It consists of set of computers and terminal devices. Okay, so what do you mean by set of computers? Set of computers is nothing but it consists of small scale computer, medium scale computer, and large scale computer. Okay, what do you mean by small scale? Okay, if you connect like less than 1,000 computers, it is called as a small scale. If you connect more than 1,000 but less than 5,000, it is called as a medium scale. If you connect more than 5,000, it is called as a large scale. Okay, so that is called as set of computers. So what do you mean by terminal devices? Any starting or ending point of a telecommunication network is called as a terminal device. Okay, so any device you take, okay, which is either a starting or an ending point, it is called as a terminal device. Okay, now we have two types of terminal devices. Okay, first is called as intelligent terminal, second is called as a dumb terminal. Okay, so what do you mean by intelligent terminal? Any device which consists of a processor. Okay, so we studied the definition of a processor. So what do you mean by processor? It is nothing but an hardware unit which executes an instruction. Okay, so if a device consists of a processor, it is called as an intelligent terminal. If a device does not have a processor, then it is called as a dumb terminal. So this is a small definition of a telecommunication network. Okay, so what do you mean by telecommunication network? It's nothing but a combination of set of computers and terminal devices. Okay, so set of computers, we have different types. Okay, terminal devices is nothing but a starting or an ending point of a telecommunication network. Again, it is divided into two types, intelligent and dumb terminal. Okay, for example, if at all you take this particular telecommunication network, now if you take point A, okay, now can I call point A, which is nothing but a computer, as a terminal? Yes. Okay, so which type of terminal a computer is? Whether it consists of a processor? Yes, it consists of a processor. That is the reason this particular terminal is called as an intelligent terminal. Okay, it is called as an intelligent terminal. Okay, so we have other point, like let us say B. Okay, if you take B, point B, now can I call point B as a terminal? Yes, point B is also called as terminal. Okay, because it is again ending point of a telecommunication network. Now which type of terminal it is? It is nothing but a dumb terminal. Okay, so this is a definition of telecommunication network. Okay, now we have certain components of telecommunication network. So what are the important components? Okay, we have 5 components. First one is called as sender, second is called as, okay, receiver, third is called as message, fourth is, okay, telecommunication network, and last one is called as protocol. Okay, so these are the components. You take any telecommunication network, you require these particular, okay, 5 components: sender, receiver, message, telecommunication network, and protocol. So what do you mean by sender? Like let us say if at all you take point A. Okay, so point A, okay, is called as sender. Okay, point B is called as receiver. What do you mean by sender? A device which is transmitting the data is called as sender. What do you mean by receiver? A device which receives the message, okay, is called as receiver. Okay, so what do you mean by message? Message is nothing but the data which a sender is transmitting to receiver. Okay, and how the data will be transmitted over a telecommunication network. Okay, so this telecommunication network can be a guided medium or unguided medium, that, okay, entire framework which we will see. Okay, and last one is called as a protocol. So what do you mean by protocol? Protocol is nothing but it consists of set of rules. Okay, set of rules, okay, which a sender and receiver will accept. Okay, so that is called as a protocol. Okay, protocol is nothing but a set of rules. Okay, for example, okay, now can I call you as a receiver? Yes. Can I call myself as a sender? Yes. Okay, so am I communicating? Yes. How I am communicating? Using internet. Okay, now do we have a protocol? Yes. Okay, we have an agreement that, okay, I should speak in a language which you can understand. So if I speak in either English, Telugu, or Hindi, you can able to understand. Okay, if I speak any other language, can you understand? Like if I teach in Japanese, okay, can you understand? No. Okay, so unless until you know Japanese, okay, so if I speak in Japanese, okay, can you understand, or can I call it as a communication? No. Okay, so what do you mean by protocol? Protocol is nothing but it consists of set of rules which are agreed by both the sender and receiver. So that is called as a protocol. Okay, so these are the components of telecommunication network. If you take any network, okay, we need these particular components. Okay, now let us move to, okay, our next topic, need and scope of telecommunication network. So need and scope of telecommunication network. So we'll be using certain diagrams for the purpose of understanding. Okay, so please don't use these particular diagrams in the exam. Okay, it is only for the purpose of understanding in order to make you visualize. Okay, so I am using this particular diagram, but these are not standard diagrams which are prescribed by ICAI. Okay, it is only for the purpose of understanding. I have created it. Okay, so let us start with the need and scope of telecommunication network. So this is one of the important concept. Okay, so what do you mean by need and scope of telecommunication network? It is nothing but advantages of telecommunication network. Okay, already I told you telecommunication network. Why do we require telecommunication network? For basically two reasons. Okay, for the purpose of transmitting the data from one point to another point. The second reason is either for the purpose of sharing, okay, any resources or information. We require this particular telecommunication network. However, we have a wide variety of uses or advantages, but in our study material, okay, they have restricted to 6. Okay, so what is the first advantage? First advantage is called as file sharing. Okay, so what do you mean by file sharing? File sharing is nothing but, okay, let us assume this is a server. These are certain clients. Okay, so what do you mean by server? Server is nothing but an advanced computer where you connect multiple processors together. Okay, so we studied the definition of processor. So what do you mean by processor? Processor is nothing but, okay, a hardware unit which executes an instructions. Okay, so if you combine few processors together, it becomes a server. Okay, so what do you mean by client? A client consists of a single processor. Okay, that definition also we'll study. Okay, so what do you mean by server? Server is nothing but an advanced computer. What do you mean by client? Client is nothing but an, okay, a computer which consists of only a single processor. Okay, so what do you mean by file sharing? Now let us assume I have certain files. Okay, I have grouped them and I have placed these particular files on the server so that the clients can access them. Okay, so this particular thing, okay, how exactly a server is sharing okay, this particular file to the client, okay, using telecommunication networks. These lines, okay, which you see, okay, these lines, okay, which you see is nothing but a telecommunication network. Okay, using this particular telecommunication network, the files will be shared from server to, okay, client. Okay, so that is called as file sharing. So how we are able to share the files? Only because of telecommunication networks. Okay, so what do you mean by telecommunication network? Okay, what's the first advantage? It is nothing but file sharing. What do you mean by file sharing? File sharing is nothing but, if at all you have a group of files, okay, these files can be shared, okay, to multiple systems, okay, using telecommunication network. Okay, so second one is called as resource sharing. So the second advantage is resource sharing. So what do you mean by resource sharing? Let us say to the server, let us assume this is a server. I have connected a printer and scanner, and using telecommunication network, we have so many clients which are connected. Okay. Now, if at all telecommunication network is not there, so what you have to do, okay, for independent personal computers, you have to attach a separate printer and scanner. For example, let us say telecommunication network is not there, and let us assume Infosys is a company. Let us say they have 70,000 employees. Okay, so for each and every personal computer, they have to maintain a separate printer and scanner. Okay, now what happens to the cost of resources? The cost of resources will increase. However, if at all we use telecommunication network, what will happen? Okay, so I have multiple computers which are connected to the telecommunication network. I have multiple computers which will be connected, okay, to the server. Okay, I'll connect printer and scanner. Okay, I connect printer and scanner. So what happens using telecommunication network? We can share this, okay, communication network resources. Okay, so all these particular network resources can be shared using a telecommunication network. Okay. Now what happens, okay, if I share telecommunication network resources, the cost of resources will come down. Okay, yes or no? Okay, like let us say if at all you have 70,000 employees, for 70,000 employees and I can maintain only 7 printers. Okay, so every computer, if they want to, okay, access the printer, they can, okay, use a telecommunication network. So what happens to the cost? The cost will be reduced and maintenance also will be reduced. What do you mean by maintenance? Okay, like let us say you have a printer, okay, and printer will be having a cartridge. Okay, now every time you need to change, I mean, you have to refill this particular cartridge. That is called as maintenance. Okay, if there are multiple printers, then the maintenance cost will be increasing. But if you use telecommunication network, the resources can be reduced, so obviously maintenance cost will be reduced. Okay, so this is the second advantage. And third advantage is nothing but remote access. So what do you mean by remote access? Remote access is nothing but, if a person from a remote area, okay, so what do you mean by remote area? Like home, okay, or okay, any other place other than organization network is called as a remote area. Okay, so any person, okay, from a remote area, if at all he is using internet or public network to enter into organization network and use the resources, then it is called as remote access. So what do you mean by remote access? Remote access is nothing but, okay, if any user, okay, what exactly he will do from a remote area, okay, using internet, if at all he is connected to the organization network, then that type of, okay, concept is called as a remote access. Okay, next one is called as fault tolerance. Now what do you mean by fault tolerance? Fault tolerance is nothing but, okay, maintaining certain, okay, additional resources. Okay, maintaining certain additional resources is called as fault tolerance. Okay, so if you see this fault tolerance, now let us say, okay, if you have only one server, okay, let us assume if you have only one server, if the user is using this particular server, if suddenly due to hardware, if the server is not working, then what will happen? Okay, can the user can access the data? No. That is the reason always we maintain certain additional resources. Okay, if something happens to server 1, what will happen? The load will be transferred to server 2, and okay, the services will be provided, okay, from server 2. Okay, so this is called as fault tolerance. In simple, what do you mean by fault tolerance? Fault tolerance is nothing but, okay, maintaining additional resources is called as fault tolerance. Okay, next one, database sharing. So what do you mean by database sharing? If you have a single database, okay, or single database which will be shared among multiple users, then it is called as database sharing. Okay, so what do you mean by database sharing? If at all you have a single database, if this single database is shared among multiple users, then it is called as database sharing. Okay, and again, how do we share this particular database? Using telecommunication network. Okay, and last one is internet sharing and security. So what do you mean by internet sharing and security? It is nothing but using www. What is www? World Wide Web. Okay, so using World Wide Web we can access any information, etc. Okay, so this is about internet sharing and security. So these are 6 advantages. Okay, these are 6 advantages of telecommunication network. What is the first advantage? First advantage is file sharing. What is the second advantage? Second advantage is resource sharing. What is the third one? Remote access. What is the fourth one? Fault tolerance. What is the fifth one? Database sharing. What is the sixth one? Internet sharing and security. Okay, so this is about need and scope of telecommunication network. Now let us move to the next concept. So let us go to the next concept, classification of telecommunication networks. Okay, so if you see telecommunication networks, networks are classified into how many types? Are 3 types. Okay, so networks are classified into 3 types. First one is called as area based classification. Second is called as function based classification. And last one is called as ownership based classification. Okay, so these are 3 types of classifications we have. Okay, so first one is area based classification, second is function based classification, third one is ownership based classification. Okay, so what do you mean by area based classification? If at all you are classifying the networks depending on the geographical area, it is called as area based classification. Okay, so this area based classification is further divided into 3 types. First one is called as, okay, and local area network. Second is called as a metropolitan area network, and third one is called as wide area network. Okay, so how many types area based classifications are classified into? It is classified into 3 types. First one is called as local area network, second is metropolitan area network, third one is called as wide area network. Okay, so what do you mean by local area network? If you are connecting the computers within a limited area, it is called as local area network. Okay, so let us see what is local area network, metropolitan area network. So let us see classification. Okay, area based. So what do you mean by area based? Area based is nothing but depending on the geographical area, we can classify them into 3. First one is local area network, second is metropolitan area network, third one is wide area network. Okay, now what do you mean by local area network? If you want to connect the computers within a limited area, then it is called as a local area network. So what do you mean by local area network? If you want to connect the computers within a very limited area, like within a building, okay, let us say I have a building 1. Okay, if I want to connect the computers, like 100 computers within the same building, okay, I have to use a network called as local area network. Okay, however, if at all I have 2 buildings, like building 1 and building 2 adjacent to each other, okay, and I want to connect the computers 100 in building 1, 100 in building 2, here also, because they are adjacent buildings, okay, I have to use, okay, a network called as a local area network. Okay, so what do you mean by local area network? Local area networks are required for the purpose of, okay, connecting the computers within a very limited area. Okay, second network is called as metropolitan area network. So why do we require metropolitan area network? Metropolitan area networks are required for the purpose of connecting the computers within a city. Okay, like, okay, to the extent of 40 kilometers. Okay, like let us say if at all you have branch 1 and branch 2. Okay, and the distance between branch 1 and branch 2 is, let us assume, 35 kilometers. Okay, let us say 35 kilometers. So which network I have to use? Because up to 40 kilometers we can use metropolitan area network. So I have to use a metropolitan area network. Okay, now whether it is used for the purpose of transmitting data and voice, yes, okay, it is used for the purpose of transmitting data and voice. What do you mean by transmitting of data? It is nothing but, okay, the text, okay, the texting, okay, we can transmit. And also it can use for the purpose of transmitting voice, okay, the voice, okay, the human voice also we can be transmitting using metropolitan area network. Okay, and whether it supports guided and unguided medium, yes, it supports both guided and unguided medium. So what do you mean by guided medium? Guided medium is nothing but a physical wire. Okay, if at all you are connecting the computers using a physical wire, it is called as a guided medium. What do you mean by unguided medium? If you don't have a wire, okay, or wireless transmission is called as unguided medium. And last one is called as a wide area network. So what do you mean by wide area network? It is nothing but if at all you want to connect the computers within a country or continent, okay, very, very large area, okay, at that time we use wide area networks. Okay, so what is the technology basically we use? We use satellite communication or undersea cable. So what do you mean by satellite communication? Like ISRO will be sending certain satellites. Okay, satellite you have again two types. Okay, one is called as a natural satellite, another is called as an, okay, artificial satellite. Okay, so for Earth, okay, natural satellite is moon. Okay, so what do you mean by natural satellite is moon? Okay, what do you mean by artificial satellite? The man-made satellite. Okay, now why do we require these satellites? For the purpose of communication. Okay, so wide area networks generally use satellite communication or undersea cable, and also these particular wide area networks also uses guided or unguided medium. What do you mean by guided? Guided is nothing but a wire transmission. What do you mean by unguided? Unguided is nothing but, okay, wireless transmission. So these are three types of area-based classifications we have. Okay, first one is local area network, second is metropolitan area network, third one is wide area network. Local area network always transmits the data within a limited area. Metropolitan area network transmits the data within a range of 40 kilometers. Wide area networks can transmit the data in a very, very large communication networks. So we are studying classification of telecommunication networks. So we are done with first one. Okay, so what is the first one? First one is area-based classifications. We are done. Okay, so this one is classified into three types: local area network, metropolitan area network, and wide area network. Now let us, okay, go to the second type of classification, function-based classification. Okay, now this function-based classification is further divided into two types. First one is client-server network, second is peer-to-peer network. Okay, now this particular client-server network and peer-to-peer network, how exactly we distinguish? Okay, now using a parameter called as server. Okay, so if a particular network consists of a server, then it is called as a client-server network. If a particular network doesn't require a server, it is called as a peer-to-peer network. Okay, so basically these particular networks are classified into two types. First one is called as a client-server network and peer-to-peer network. If a network consists of a server, it is called as a client-server network. If a network doesn't have an server, then it is called as an peer-to-peer network. Okay, so if you see this particular client-server network, we have 5 topics in client-server network. Okay, so we'll see one after other. Okay, so first one is what is a client-server network. Second is, okay, working of client-server network. Third one is characteristics of client-server network. Fourth one is issues, and last one is multi-tier architecture. Okay, now let us see the first one. What is a client-server network? Okay, so classification of telecommunication networks, function-based classification. Okay, so function-based classification. Now let us see first topic. Okay, client-server network. Okay, so here, okay, we need to understand. Okay, so we need to understand sorry, what is a client-server network. Okay, first we need to understand what is the definition of client-server network. Client-server network is nothing but if a powerful computer is connected to a less powerful computer, that type of network is called as a client-server network. So what do you mean by client-server network? It is nothing but if a powerful computer is connected to a less powerful computer, it is called as a client-server network. Okay. So if you see server, okay, server consists of multiple processors. Okay, now can I call it as a powerful computer? Yes. Okay, server is always a powerful computer. If you see client consists of only one processor. That is the reason it is called as a less powerful computer. So if you connect powerful computer with a less powerful computer, then it is called as a client server network. This is a definition which we have. Okay, so if you see this particular client server network, we have a standard definition for server. Okay, now let us see what is a server. Okay, a server is nothing but it consists of single or multiple processors which provides the following services. Okay, so what do you mean by server? Generally, okay, it doesn't consist of a single, okay, but it consists of multiple processors which provide services. What are the services it provides? Computation service, communication service, and database service. Okay, now what do you mean by computation? Like let us say if the client wants to perform addition, okay, addition of 20 and 30, so the client will send that particular instruction to the server. Server will perform that particular activity or instruction or execute an instruction. The result will be sent back to the client. So that is called as computation. So what do you mean by computation? Computation is nothing but processing. What do you mean by processing? Conversion of data into information. Okay, that service it provides. Next one, it provides a communication service. Okay, whether client can communicate with the server? Yes. Okay, I'm transmitting the data from client to server. That means I'm communicating. Okay, so whether server can communicate back to client? Yes. Okay, that also should happen. Okay, so that is called as a communication service. And database service. What do you mean by database? Okay, we already studied in need and scope of telecommunication networks. Okay, if you have a single database, if this single database is shared among multiple users, that is called as database sharing, okay, or database service. And for what purpose will be using this particular thing? It is used for business purpose. BP means business purpose. Okay, so this is a standard definition for server. So what do you mean by server? Server is nothing but it consists of single or multiple processor which provide certain services. So what are the services it provides? Like computation service, communication service, and database service for business purpose. The same way we have a definition for a client. So what do you mean by client? Client consists of always a single processor. And what are the services it provides? Like it provides presentation service, communication service, and database service for business purpose. We already know what is a communication service and what is a database service. Okay. Then what do you mean by presentation service? Again, if I use the instruction add 20, 30. Now, if I send this instruction to the server, server will compute that. Okay. Calculate that. Okay. So what is the result? The result is 50. The 50 will be displayed on the screen of the user. 50 will be displayed on the screen of the user. So that is called as presentation. Okay, so what do you mean by presentation? Presentation is nothing but showing the result to the end user is called as presentation. Okay, so this is about client server network. If they ask in the exam, explain about client server network, you need to write the definition of what is a client server network. You need to write the definition of a server. You need to write the definition of a client. Okay, what do you mean by client server network? Client server network is nothing but if a powerful computer is connected to a less powerful computer, it is called as a client server network. Okay, so what do you mean by server? Server consists of multiple processors which provide certain services. Okay, and what do you mean by client? A client consists of a single processor. Okay, now let us move to you have one more question called as explain different types of clients. So clients are basically divided into three types. First one is called as fat client. Sorry. Second is called as thin client, and third one is called as an hybrid client. Okay, so what do you mean by fat client? Fat client is nothing but if the processing of data is done by the client itself, it is called as fat client. Sorry. What do you mean by fat client? Fat client is nothing but if the processing is done by the client itself, it is called as fat client. For example, so if at all you see add 20 and 30, if add 20 and 30 is done by the client itself or processed by the client itself, then this particular client is called as a fat client. In other words, if the client is processing the data without depending on the server, then it is called as a fat client. So next one is called as thin client. What do you mean by thin client? Thin client is nothing but if the processing of data is done by the server, then it is called as a thin client. That means, if the client is sending add 20 and 30, if the server is processing or executing that instruction and sending the result 50 to the user, so who processed that instruction? Server processed the instruction. So that type of client is called as a thin client. So what do you mean by thin client? Thin client is nothing but if the processing of data is done by the server, it is called as thin client. And last one is called as a hybrid client. What do you mean by hybrid client? Hybrid client is nothing but if the processing is done by the client, however, the data is stored on the server, then it is called as an hybrid client. So these are three types of clients which we have. Okay, so what is the first one? First one is nothing but an a fat client or thick client. What is the second one? Second one is called as thin client, and third one is called as an hybrid client. Okay, so this is about a client server network. So what do you mean by client server network? Okay, we have completed. Now we are studying function based classification. In function based classification, okay, we completed what is a client server network. The same way we have second topic. We have second topic. Okay, explain. Explain working of client server network. Okay, this is the second topic which we have in function based classification. We have second topic, working of client server network. Okay, so explain working of client server network. Now what do you mean by client server network? We have studied. Okay, now server is nothing but, can I call it as an advanced computer? Yes. Okay, what do you mean by advanced computer? If you connect multiple processors, then it is called as an advanced computer. Okay, so what exactly a server will do? A server will do a service, okay, called as validation. Okay, so what do you mean by validation? Validation is nothing but verification of the client. Okay, like let us say to the server I connect a printer. Now, okay, if the client wants to access the printer, so client will send a request that server, I want to use the printer. Okay, now what exactly server will do? Server will perform a validation. So what do you mean by validation? Verification. Whether you are an authenticated user or not, it will verify. Okay, how does it verify? It will ask the client, okay, to enter user ID and password. Okay, so once the client enters user ID and password, it will verify whether the user ID and password is correct or not. Okay, if the user ID and password is correct, then it will provide an connection to the printer so that a client can access the printer. So that concept is called as validation. So what do you mean by validation? Validation is nothing but verification of the client whether he is an authenticated user or not. Okay, so this is the first layer. So how do we connect a client and server together? We use a middleware, or it is also called as a network layer. Okay, so what exactly is a middleware, or what exactly is a network layer? It's a frequently asked 2 marks question. Okay, so what do you mean by middleware or a network layer? Network layer or middleware connects a server and client together, and it provides certain services. Okay, so what are the services it provides? Okay, it provides 5 services. A middleware provides 5 services. First one is called as, so what do you mean by middleware? It is nothing but it connects a client and server together. How many services it provides? It provides 5 services. First one is called as a directory service. Second is called as queuing service. Third one is called as communication service. Fourth one is database service, and last one is print service. We already know what is communication service, what is database service, and what is print service. Okay, print service is nothing but it allows it allows the client to access the printer. Okay, communication and database service, which we have already studied. Okay, now we need to understand what is directory and queuing service. Okay, so what do you mean by directory service? Okay, if you see a directory, so we have a name, it is called as a domain name basically, and we have its corresponding IP address, because how a client will be connected to the server, they have to use an IP address, like 192.3.2.1, this is nothing but an IP address, this is nothing but an IP address, Now, being a user, can I remember the numbers? It is not possible. That is the reason we require a directory service. Now, in the directory service, we have a domain name like fb.com, and its corresponding IP address. Now, when I type on the internet browser www.fb.com, and if I press enter, what will happen? It will go to the directory and it will take what is the domain name fb.com. It takes its corresponding IP address and it connects the client to that particular IP address server. So this is called as a directory service. Second is called as a queuing service. So what do you mean by queuing service? Queuing service is nothing but, like, let us say if at all you have multiple clients, like let us say C1, C2, C3. Okay, let us say this is 1, this is 2, and this is 3. Okay, so if 3 systems wants to use the printer, now can I provide 3 computers to access the printer at the same time? It is not possible. So what exactly network will do? Network will maintain a queue, okay, or it is called as queuing. Okay, so what do you mean by queuing? Queuing is nothing but standing in a line. Okay, so how does it will allow clients to access the printer? It uses an software or an algorithm called as first in first out. So whoever enters first, he will go first and he will access the printer. Once client 1 completes his job, client 2 will go. Once he also completes his job, and client 3 will go. Okay, so this is called as a queuing service. So this is about working of client server network. Okay, so what do you mean by working of client server network? How exactly this client server network works? And the basic important concept here is you need to understand what is a middleware. Okay, so it's a very, very important, okay, definition. So what do you mean by middleware and what are the services it provides? Okay, sorry. So this is the second topic in client server network, working of client server network. Okay, now let us move to, okay, so we are done with 2 topics. What is the first one? First one is explain about client server network. What is the second topic which we are done? Okay, explain about working of client server network. You need to be very careful because in the previous question to this question, okay, only one word changes. Okay, working. Okay, in the previous question you will not have working. Here you will be having working. Okay, so if at all you have working, you need to write this answer. If at all you don't have working, you need to write the definition parts. Okay, so this is about client server networks. Now let us move to next one. Next question. Characteristics of client server network. Okay, so third question in client server network. Explain characteristics of client server network. How many characteristics we have? Basically, we have 5 characteristics. Okay, first one is called as service. Second is called as shared resource. Okay, third one is called as data integrity. Okay, fourth one is called as, okay, mix and match. Okay, and last one is called as scalability. Okay, so these are 5 characteristics of client server network. Okay, so what are 5 characteristics? First one is service, second is shared resources, third one is data integrity, fourth one is mix and match, and fifth one is scalability. Okay, so you need to write the side headings correctly. Okay, we don't want, okay, in the same order, but you should not change the side headings. Okay, so first one is service. What do you mean by service? Okay, always a client server network consists of service provider and service receiver. Yes or no? Okay, who is providing the data? Always computation is done by server, so service provider is server. Who is, okay, receiving the result? Okay, client will receive the result, so it is called as service receiver. Okay, so what do you mean by service? Service is nothing but it consists of service provider and service receiver. Service provider being the server, service receiver being the client. Okay, now this shared resources we already know. Okay, it allows sharing of, okay, network resources like printer, scanner, etc., so that multiple users can access these particular resources at the same time or simultaneously. That is called as shared resource. Now, what do you mean by data integrity? Data integrity is nothing but maintaining the data at one place. Okay, always in client server network, we maintain the data, okay, only on the server. For example, again, if you take this particular diagram, so what do you mean by data integrity? Data integrity is nothing but always the data will be maintained at a server location. Okay, the data will be maintained at a server location. Okay, so what happens if I maintain the data at a server location? The maintenance of data becomes easier, okay, rather than, okay, if you maintain the data in different clients. Okay, what you have to do, you have to take the backup from this client. Okay, so you need to basically take a pen drive, you have to connect the pen drive, you take the data from this particular computer, then you have to go to this computer, again you have to take the backup, then you have to go to third computer, you take the backup, fourth computer, you take the backup. Okay, instead of that, if I maintain the data only on the server, what I have to do, if I want to take a backup, okay, I go to the server, I connect a pen drive and I copy the data only from one computer. So that is called as maintenance of data. So if at all you are using a client server network, what will happen? The maintenance of data becomes very, very easy. Okay, so that is data integrity. So what do you mean by data integrity? Data integrity is nothing but maintaining the data at one place so that, okay, we can maintain the data easily. Okay, so that is called as data integrity. Next one is called as mix and match. So what do you mean by mix and match? Mix and match is nothing but the client server network should be independent of hardware and software. Okay, what do you mean by independent of hardware and software? Independent of hardware and software is nothing but, Okay, if the server is from IBM company and if the client is from HP company, okay, they have to provide a communication between them. Okay, they should not say you are from different company, I will not communicate with you. No, okay. So irrespective of the hardware, it has to provide the communication. Okay. Now let us assume, okay, if the server is having a Unix operating system, whereas client is having a Windows operating system, again, because there's a difference in the software, okay, so it should not say I will not communicate with you, okay. So irrespective of which hardware and which software you are using, okay, it has to provide the communication. That is called as mix and match, okay. And last one is called as scalability. So what do you mean by scalability? Scalability is nothing but, okay, it should allow, okay, adding and removing of resources easily, okay. So what do you mean by adding and removing of resources? For example, if at all I want to connect the computer, okay, so I have to easily connect the computer. If I want to remove the computer, I can easily remove the computer. That is called as scalability, okay. It is just like, okay, like let us say if at all you have a personal computer, and how do you connect the internet, sir? You take the wire and you push that particular wire into a port, okay. So that is called as connecting. So how much time it takes, sir? Hardly 20 minutes, 20 seconds, etc. it will take if you have a wire, okay. So, okay, that is called as, okay, connecting easily. If you want to remove the internet connection, just remove it, okay. So, okay, it hardly takes 2 or 3 seconds, okay. So, what do you mean by scalability? It should allow to add number of computers or it should allow to remove the number of computers. That is called as, okay, characteristics of client-server network. Now, this is very, very important for your exam. Okay, so explain the characteristics of client-server network. We have 5 characteristics. First one is service. Second is shared resources. Third one is data integrity. Fourth one is mix and match. And last one is scalability. Sorry. Now, let us move to the fourth topic in client-server network. Now, after this, okay, so we have, okay, last 2 topics. Okay, so what are the issues in client-server network? So what are the basic issues of client-server network and multi-tier architecture? Okay, so what do you mean by issues? Okay, so we have 2 issues basically. If server goes down or crashes, client cannot access it. Okay, so this, okay, we need to, if you have only one server, if the server goes down, can a client access the data? It is not possible. This is the first issue. Okay, second issue, if you see multiple, okay, if multiple people or users are accessing the data simultaneously, then, okay, it takes little time to process. Okay, I told you queuing service. Okay, so if you see queuing service, if multiple, okay, clients are requesting to access the printer, what exactly network will do? Network will maintain a queue, C1, C2, C3. Okay, so who will go first? C1 will go first. Okay, it will be processing, okay, or printing its documents. Then C2 will go. Okay, so what happens? C2 has to wait certain time to get, okay, it's to get the access of the printer. Okay, so if simultaneous access to data happens, okay, it takes little time to process. That is the reason, if at all your results are announced, okay, so what happens, okay, at that particular point, if you try to access, okay, if you try to access the server, okay, it says loading. Why? Because, okay, if multiple users are, okay, accessing the server at the same time, it takes little time to process the data. So these are the 2 issues. Okay, so what is the first issue? First issue is nothing but if server goes down or crashes, then a client cannot access the data. What is the second one? If multiple users are accessing the data at the same time, okay, it takes little time to process the data. Okay, multi-tier architecture. So what is multi-tier architecture? You have 3 types actually. Before you understand this multi-tier architecture, you are supposed to understand the 3 layers of, okay, multi-tier architecture. First one is called as a presentation layer. Second is application layer or a business layer. And last one is a database layer. Okay. So what do you mean by presentation layer? Presenting the data to the user is called as presentation layer. Okay. Like let us say, okay, I told you add 20, 30. Server will process that particular thing and the result will be displayed on the client. Okay, that is 50. Okay, it's an example of presentation. Or let us say if at all you take your exam application form. Okay, so what exactly they will do? Okay, they will prepare this particular web page, and once, okay, you say your server provides that exam application form, you have to fill in the details and you say submit. Okay, so what exactly it is doing? Okay, using presentation service, the server is collecting the data from the user. Okay, so either the presentation layer is required to present the data to the user or collect the data from the user. Second is called as an business layer. Okay, what do you mean by business layer? It is nothing but, okay, presentation layer will send the data to the application layer, and internally application layer will send the data to the database layer. Okay, it acts like a bridge between presentation and database layer. Okay, and last one is called as a database layer. Why do we require this layer? This layer is required for the purpose of storing the data permanently. Okay, so these are the three layers which we require, okay, in order to understand multi-tier architecture. Okay, so now this multi-tier architecture is classified into three types. First one is called as one-tier architecture. Second is called as a two-tier architecture. Third one is called as a three-tier architecture. Simple thing. Okay, so if a single computer, or it is called as a standalone computer, if a single computer is having all the three layers, presentation layer, business layer, and database layer, then it is called as a one-tier architecture. Okay, so what do you mean by two-tier architecture? If the presentation layer is at the client side and database layer is at the server side, then that type of architecture is called as a two-tier architecture, where you have a clear separation between presentation layer and a database layer. That type of architecture is called as a two-tier architecture. So what do you mean by three-tier architecture? In three-tier architecture, the presentation layer will be at the client side, the business layer will be on the application server, and okay, the database will be on the database server. Okay, this is called as three-tier architecture. Okay, so these are three tiers in multi-tier architecture. So with this, we are done with client-server networks. Okay, so we are in classification of telecommunication networks. So we are studying, okay, classification of telecommunication networks. So we are done with, okay, area-based classification. So we started function-based classification. How many types function-based classification we have? Two types. First one is client-server network. Second is peer-to-peer network. In client-server network, we have completed 5 topics. What is a client-server network? Working of client-server network, characteristics of client-server network, issues in client-server network, and multi-tier architecture. Okay. Now let us, okay, go to the second one, that is called as a peer-to-peer network. Okay. So let us see what is a peer-to-peer network. Now, what do you mean by peer-to-peer network? Peer-to-peer network is nothing but, okay, where you will not have the server, okay, so where you will not have a server, but how do you connect these particular computers? The computers will be connected, okay, using okay, how exactly the computers are connected? Computers are connecting using a hub or a switch. Okay, so using a hub or a switch, using a copper wire, okay, we connect, okay, the computers together, okay, so that they can share the data with one another. Okay, and it is half dozen, not a dozen, HALF, half dozen. Okay, so it is required for the purpose of connecting a half dozen computers. Okay, so what do you mean by peer? Peer means equal. Okay, now we studied client-server network definition, where I told you client-server network is nothing but if a powerful computer is connected to a less powerful computer, it is called as a client-server network. Okay, here, okay, there is no concept of powerful and less powerful. Okay, every computer will be treated equally. And how do you connect these computers? These computers are connected using a switch or a hub. Okay, and how exactly these computers are connected? Using a copper wire. Okay, so what are the certain examples of this particular peer-to-peer network? Freenet and Napster are examples of this peer-to-peer network. And where do we use these particular networks? It is used in small offices. Okay, so this is about function-based classification. Okay, so we are done with, okay, so we are studying classification of telecommunication networks. So we are studying classification. So we are done with area-based classification. We are done with function-based classification. So what is function-based classification? We have two types: client-server network, peer-to-peer network. We are done with these 5 topics. Okay, we are done with peer-to-peer network. Now let us move to the last one, ownership-based classification. Okay, so this ownership-based classification is further divided into 3 types. First one is called as a public network. Second is called as a private network. Third one is called as a virtual private network. Okay. So how many types we have? Ownership based classification is further divided into 3 types. First one is called as a public network. Second is called as a private network. Third one is called as a virtual private network. Now let us see the definitions of this ownership based classification. So let us see ownership based classification. So ownership based classification, as I said, we have 3 types. First one is public network. Second is private network. Third one is virtual private network. Okay. So what do you mean by public network? Public network is nothing but if a network is used by any organization, there will not be any distinguishing between the organization. Any person can able to use that particular network. That network is called as a public network. Now, who will maintain these networks? These networks are maintained by third parties. Okay. Now, example for this particular, okay, who are third parties? Third parties are nothing but ISP providers, okay, internet service providers, okay. So, what is an example for public network? Internet is a perfect example for public network, okay. Now, what do you mean by private network? A private network is nothing but if a network is used only by the employees of an organization, then that type of network is called as a private network. Okay. Now, who will maintain this network? These networks are maintained by the organization itself. Okay. So, like let us say Infosys. Infosys will maintain its own data. Okay. Sorry, own network. Okay. That type of network is called as a private network. Okay. And last one is called as a virtual private network. What do you mean by virtual? Virtual is nothing but an imaginary. Okay. What do you mean by virtual? Virtual is nothing but imaginary. Okay. What do you mean by virtual private network? Virtual private network is nothing but so what do you mean by virtual private network? Virtual private network is nothing but virtual means imaginary. So we already studied remote access. Okay. So what do you mean by remote access? Remote access is nothing but if a user, okay, from an home location or a remote location, if at all he enters into a public network, and through public network, if at all he enters into a private network, okay, so public network can be accessed by any user, whereas a private network can be accessed only by the employees of that particular organization. So what exactly is a virtual private network? A virtual private network is nothing but if a user using a public network, if at all he enters into a private network to use the resources, then that type of network is called as a virtual private network. Okay. So what do you mean by virtual private network? If a remote user connects into organization network or a private network using a public network is called as a virtual private network. Now, whether this virtual private network okay, provides security? Yes, it provides security by the concept of encryption and decryption. So, what do you mean by encryption? Like, let us say I want to try. So, if I transmit high, so how do I protect the data? Because the public networks are not secured. Okay, public networks are not secure. Okay, always there will be certain hackers who will be changing or modifying the data. Okay, so how do I protect the data? I use a concept of encryption and decryption. So what do you mean by encryption? I take this plain text, PLAIN, plain text like hi. I use a mathematical formula plus 3, ABCDFGHIJK. Sorry, ABCDFGHIJK. Okay, it will be converted into K. Okay, ABCDFGHIJKL. It will be converted into L. Okay, so using mathematical formula, I convert into KL. I transmit KL to the receiver. Now, even though hacker sees this KL, he will not understand what exactly is the information and he cannot modify the data. So, this KL will be again converted using -3 and okay, I convert them into a plain text. Okay. This is called as encryption and decryption. So what do you mean by encryption and decryption? Conversion of a plain text into cipher, CIPHER, cipher text is called as an encryption. What do you mean by decryption? Decryption is nothing but conversion of cipher text back to plain text is called as encryption and decryption. So even if at all you are using your internet banking website, at the time when you are providing your password, okay, and when you say submit, what will happen? Your password will expand. Okay, why? Because it uses an encryption for the purpose of protecting your password. Here I encrypted only once, but in the passwords it will be encrypted 128 times or 216 times. So even a hacker tries to hack or tries to see your password, it takes around 70 years, okay, for the purpose of decrypting. That is the reason our, okay, passwords are safe, okay, because of encryption and decryption. The same concept will be used in virtual private networks in order to protect the, okay, in order to protect the transmission of data. So this is about classification of telecommunication networks. Okay, so with this we are done with classification. So if you see classification, so if you see classification, so classification, how many types we have, sir? We have 3 types. Okay, so this is about classification. So how many types we have? We have 3 types. First one is area-based classification. Area-based classification is further divided into 3: local area, metropolitan area, wide area network. Function-based classification, okay, is classified into 2 types. First one is client-server network. Second is peer-to-peer network. Client-server networks are further classified into 5, okay, topics: client-server network, working of client-server network, characteristics of client-server network, issues in client-server network, and multi-tier architecture. Peer-to-peer networks, okay, we have studied, okay, peer-to-peer network. And ownership-based classification is divided into 3 types: public network, private network, and virtual private network. So this is about classification of telecommunication networks. Okay, now let us move to the next topic. We have a small concept called as network computing. So what do you mean by network computing? Network computing is nothing but, okay, so it depends on, okay, where the processing is going on. Okay, so if, okay, the network resources or processing is done at a central location, then it is called as centralized computing. So what do you mean by centralized computing? It is nothing but if the computing or processing is done at a central location. Okay, if the computing or processing is done at a central location, or if the network resources are shared, okay, between certain clients, then it is called as centralized computing. So what do you mean by decentralized computing? Decentralized computing is nothing but if every computer or a workstation has its own hardware and software resources, it is called as decentralized computing. Okay. So what do you mean by network computing? Computing means processing, okay, where exactly the processing is happening. Okay, if the processing is happening at a central location, it is called as centralized computing. If at all the processing is done on an individual computer, then it is called as decentralized computing. Okay, so in your study material, you have a difference between, okay, centralized and decentralized computing. Okay, so what do you mean by centralized computing? Centralized computing is nothing but what do you mean by centralized computing? Centralized computing is nothing but if each workstation has its own hardware and software resources, then it is called as a centralized or decentralized computing. Okay, so this is a difference between centralized and decentralized computing. Now let us move to the next concept. Okay. There's another, okay, topic called as network topology. So what do you mean by network topology? Network topology is nothing but how exactly we connect, okay, this particular computers and its resources for the purpose of communication. Okay, so this network topology is nothing but a geometrical arrangement of computers and its resources. Okay, how many types of topologies we have? We have, okay, 4 types of topologies. First one is called as a mesh topology. Second is called as ring topology. Third one is called as bus topology, and last one is called as, okay, a star topology. So we have basically, okay, we have basically how many types of topologies? So we have 4 types of topologies. First one is called as mesh topology. Second is ring. Third one is bus, and last one is star topology. Okay. So what do you mean by mesh topology? Mesh topology is nothing but if every computer is connected to all other computers in a network, then it is called as mesh topology. For example, here, if at all you see, okay, computer A is connected to B, it is also connected to C, it is connected to D, and it is connected to E. Okay, if every computer is connected to all other computers in a network, then it is called as a mesh topology. Okay, So what exactly is a mesh topology? If every computer is connected to all other computers in a network, it is called as a mesh topology. And okay, this particular topology consists of a dedicated path. Okay, so what do you mean by dedicated path? If I want to transmit the data from A to B, I have an dedicated path so that I can transmit the data. Okay, now where do we use this particular this particular networks? These networks are used in military applications. Okay, these networks are used in military applications. Okay, however, what is the disadvantage of these particular networks? The main disadvantage is it requires a huge infrastructure. For example, if I want to connect 5 computers, every computer is connected to 4, okay, n minus 1, where n is number of computers in a network. Like let us say if I want to connect 1000 computers, each computer should be connected with 999. Okay, so it requires a huge infrastructure. That is the reason we cannot use this particular mesh topology for the purpose of developing a larger networks. Okay, so however, this particular network topology is mesh topology is called as a powerful, or it is called as a robust network. Okay, why it is called as a robust network? Because if I want to transmit the data from one computer to another computer. Like let us say I want to transmit the data from A to C. Okay, now do we have a dedicated path? Yes, we have a dedicated path. Now let us assume if this path is not working, okay, A to C path is not working, can I transmit the data with using another path? Yes, okay, I can transmit. I have multiple paths. Okay, I can transmit from A, B to C, or I can transmit from A, E to C. Okay, so I have multiple paths for the purpose of transmitting the data. That is the reason it is called as a powerful network, or it is called as a robust network. Okay, because the chances of errors will be very low. Okay, now what do you mean by ring topology? Ring topology is nothing but if you connect the computers with adjacent to two computers, then it is called as a ring topology. So what do you mean by ring topology? If every computer is connected to adjacent to two computers, then it is called as a ring topology. And these topologies are called as unidirectional. What do you mean by unidirectional? Always the data will be moving either clockwise or anti-clockwise. Okay, so that is called as ring topology. Okay. After that, okay, we have a star topology. Star topology is nothing but it is equivalent to a peer-to-peer network, where you will be having a central controller, and to the central controller all the computers are connected. That is called as a star topology. And how do you connect the computers in a bus topology? You have a central cable. To this cable, okay, all the computers are connected, and each cable consists of a start point and end point. That is called as a bus topology. So this is about network topology. So what do you mean by network topology? Network topology is nothing but how do you connect the computers geometrically for the purpose of transmitting the data. How many types of topologies we have? 4: mesh topology, ring topology, star topology, and bus topology. Okay, so this is about topologies. Now let us move to the next concept: transmission modes. Okay, so what do you mean by transmission modes? Transmission modes always deals with the direction of flow of data. Okay, so always this particular transmission modes always deals with in which direction the data is flowing. Okay, so how many types of transmission modes we have? We have 3 types of transmission modes. First one is called as a simplex transmission mode, second is called as a half duplex transmission mode, and last one is called as a full duplex transmission mode. Okay, so what do you mean by simplex transmission mode? If the direction is only in one direction, it is called as simplex. For example, if the data is flowing from a computer to printer, then that type of transmission is called as a simplex transmission. Okay, example, if a computer is transmitting the data to the printer, then it is called as an Okay, so what do you mean by half duplex transmission? So half duplex transmission is nothing but if the direction of flow of data is in both ways, okay, not at the same time, then it is called as a half duplex. Okay, a perfect example is So what do you mean by half duplex? Half duplex is nothing but the direction will be in both directions at the same time. Okay, sorry, not at the same time. For example, this traffic constables will be using this walkie-talkie. Okay, so the data will be transmitted. Okay, not at the same. I mean both directions, but not at the same time. That means one person will talk and he'll say okay over, so that the other person can talk. Okay, so this type of communication is called as a half duplex communication. So what do you mean by full duplex communication? Full duplex communication is nothing but the direction will be in both directions at the same time. Okay, so that is called as a full duplex transmission. A perfect example is cell phone communication. Your cell phone communication is a full duplex transmission. So what do you mean by transmission mode? Transmission modes always deals with what is the direction of flow of data. How many types we have? We have three types. First one is called as a simplex transmission. Second is half duplex transmission. Third one is full duplex transmission. Now next one is, the next topic is digital data transmission. So what do you mean by digital data transmission? Digital data transmission is nothing but how do we transmit binary data in a telecommunication network? Okay. So what do you mean by digital data transmission? It is nothing but how do we transmit binary data in a telecommunication network? Okay. Now this particular transmission is further divided into two types. Okay. So what do you mean by binary? Binary is nothing but zeros and ones. Okay, it's called as binary. Okay. So how do you transmit this particular digital data or binary data in a telecommunication network is called as digital data transmission. Okay. Now this particular digital data transmission is divided into two types. First one is called as serial transmission. Second is called as parallel transmission. Okay. So what do you mean by serial transmission? If at all you have a single wire or a single transmission medium where you can transmit one bit after other bit. Okay. So if at all you see here, I have 1 1 1 0 1 1 0 1 0 1. Okay. So if I am transmitting one bit after other bit, for example, first second I transmit 1, second I transmit 1, third second I transmit 1, fourth second I transmit 0, fifth second I transmit 1. Like this, if at all I am transmitting one bit after another bit, then it is called as a serial transmission. So what do you mean by serial transmission? It should satisfy two conditions. One, it should have a single transmission medium and it can transmit one bit after another bit. Okay. Now what do you mean by parallel transmission? Parallel transmission is nothing but it should require more than one wire. And it can transmit more than one bit, then that type of transmission is called as a parallel transmission. Okay. So you have a serial transmission. In serial transmission, you have a single wire and you can transmit only one bit after another bit. You have a parallel transmission where you have more than one wire and you can transmit more than one bit. Okay. Now which is costly? Parallel is costly because you need more infrastructure. Okay. Whereas a serial is less costly. However, which is used in longer distances. Whichever is cheaper is used in longer distances. So which is cheaper? Serial is cheaper. That is the reason it is used in longer distances. Whereas where do we use this parallel transmission? Parallel transmission is used in shorter distances. Okay. So this is about serial transmission and parallel transmission. So serial transmission and parallel transmission is nothing but how do we transmit the binary data between sender and receiver. However, if at all you see serial transmission, the serial transmission is further divided into two types. Okay. First one is called as asynchronous transmission. Second is called as synchronous transmission. So how many types of serial transmissions we have? Two types. First one is called as asynchronous transmission. Second is called as synchronous transmission. Okay. So what do you mean by asynchronous transmission? In this asynchronous transmission, how many transmission lines we have? Because it is a serial transmission, it has only a single transmission medium. Now, when do we use asynchronous transmission? When do we use synchronous transmission? Okay. And why asynchronous and synchronous is required? Okay. And how exactly we transmit the data, that we'll see in this particular topic. Okay. So if the devices are at different speeds, then we go for asynchronous transmission. If the devices are at same speed, then we'll go for synchronous transmission. Okay, so please remember, if the devices are at different speed, then we go for asynchronous transmission. If the devices are at same speed, then we go for synchronous transmission. Okay, so like let us say, what do you mean by different speed? If the sender is sending 100 bits per second, but the receiver is receiving only 50 bits per second. Okay. So that means the devices are at different speed. Okay. What do you mean by same speed? Okay. If the sender is transmitting 100 bits per second and the receiver is receiving 100 bits per second, then it is called as the devices which are same speed. Now let us see how the data will be transmitted. Okay. Now you take the data. Let us say you have certain data. So what do? Okay. You convert this data into certain packets. Okay. So what do you mean by packet? Packet is nothing but a small subset of data. For example, I want to transmit hi, how are you? Okay. So instead of sending hi, how are you at the same time, what do? Hi in one packet, how in another packet, are in another packet, you in another packet. So I'll transmit the data in 4 packets. Okay. So because the devices are at different speed, I use asynchronous method. So each packet consists of a start bit. Okay. And start bit is represented by 0 and end bit is represented by 1. Okay. Now inside, okay, this is a standard format for each and every packet. Okay, inside you have a data. So if you see a packet consists of a start bit and end bit. Start bit is represented by 0, end bit is represented by 1. Okay, and always once a packet is transmitted, you have to wait for some time. That is called as gap. Okay, so you have to wait for some time and you transmit the next packet. Again wait, transmit the next packet. So always you have to maintain the gaps. Okay, in asynchronous transmission. Why you need to maintain the gap? Because the devices are at different speed. Okay, if you continuously transmit the data, then what will happen? It will not be it will not be it will not be a proper transmission. Always you need to transmit the data in gaps. Okay, so what do you mean by synchronous transmission? In synchronous transmission, okay, how the data will be transmitted? When do we use synchronous transmission? Synchronous transmission is used when the devices are at same speed. Okay, so here in synchronous transmission, there is no requirement because the devices are at same speed. There is no requirement to convert the data into packets. Instead, the entire data will be transmitted in a single frame, and each frame consists of sync bits SYNC. Okay, it is called as sync bits SYNC. Okay, so why do we require sync bits? It is nothing but a common protocol. So what do you mean by protocol? Protocol is nothing but where the sender and receiver will agree for something. Okay, so why do we require X? If the receiver receives X, it understands it is the starting of the starting of the data, and if at all it receives Y, okay, it understands as an ending of the data. So this is how the transmission happens. Okay, so this is called as a synchronous transmission, where the entire, instead of dividing the data into packets, the entire data will be transmitted in a single frame. Okay, so this is about digital data transmission. So we studied. So what do you mean by digital data transmission? It is nothing but how do you transmit the binary data in a telecommunication network. We have 2 types. First one is called as a serial transmission. Second is called as a parallel transmission. So serial transmission is further divided into 2 types. First one is called as a synchronous transmission. Second is called as asynchronous transmission. So this is about digital data transmission. Now after that, we have transmission techniques. Okay, as I said, these all diagrams are only for the purpose of understanding. Okay, you're not supposed to draw these particular diagrams in your exam. These are not standard diagrams. Only I've created these diagrams in order to understand the concept. Okay, let's move to the next one, transmission techniques. Okay, so what do you mean by transmission techniques? Transmission techniques are further classified into 2 types. First one is called as broadcast networks. Second is called as switched networks. Okay, so how many types of transmission techniques we have? We have 2 types of transmission techniques. First one is called as a broadcast network. Second is called as a switched network. Okay, so what do you mean by broadcasting? A simple concept. Okay, if many computers are connected to, if a single sender is transmitting the data to all the computers or multiple computers which are connected to it, then that type of transmission is called as broadcast networks. Okay, so what do you mean by broadcasting? Broadcasting is nothing but you have a single sender, okay, where the data will be received by multiple recipients. Okay, so that is called as broadcasting. Okay, so example, cricket broadcast, cricket broadcast, news broadcast, etc. Okay. Next one is called as switched networks. Now these switched networks are divided into 3 types. First one is called as circuit switching, second is packet switching, and third one is message switching. Okay, so why do we require these switched networks? Because network topology, which we have already studied, network topologies has restriction. That means, okay, we cannot able to develop a larger network using network topology. That is the reason we'll move to switched networks. Okay. Now switched networks are of three types. First one is circuit switching. Second is packets. Third one is message switching. Okay. Now what do you mean by circuit switching? Circuit switching is nothing but here you take any network. We need to transmit the data from sender to receiver. Okay. So what exactly we do as a first step? Okay. So let us see this. Okay, circuit switching. So what exactly we do in first step? Okay. So we take the data and convert the data or divide the data into certain packets. Okay. So packet is nothing but a subset of data. So I took the data, I converted them into 4 packets, 1, 2, 3, 4. Okay. So once I convert the data into packets, okay, circuit switching has to establish a path. Okay. Now let us assume you have one, okay, these are nothing but switches. Okay. So 1, 2, 3, 4, 5 switches you are having. Okay. So if you see these particular switches, okay, so you have a computer A, you have a computer B, and you want to transmit the data from A to B. Okay, so what is the first step? You take the data and you convert the data into packets. Okay, now how the data will be transmitted in circuit switching? If all the packets are moved on the same path, then that type of transmission is called as circuit switching. Okay, so what do you mean by circuit switching? Here in circuit switching, the data will be divided into packets, and if all the packets moved in the same path or transmitted in the same path or a dedicated path, that type of transmission is called as circuit switching. Now once all the packets are received at the receiving end, okay, we disconnect it. Basically, it consists of 3 phases. First, divide the data into packets. Okay, establish a dedicated path. Once all the packets are transmitted, disconnect the path. Okay, so this is how the transmission happens in circuit switching. Now let us move to packet switching. How the data will be transmitted in packet switching? In packet switching also, we want to transmit the data from A to B. Okay, so here, first step is same. What is first step? Data will be divided into certain packets. However, now each packet is affixed with source and destination address. For example, I want to transmit the data from A to B. So I divide the data into packets, and each packet should have an source address. Generally, it will be an IP address, source address, and destination address A and B. Okay. For each and every packet, we need to affix, okay, this A and B, which is nothing but source and destination address. Okay. Now once you affix the source and destination address, all the packets are released over a network, and each packet will take its own route for the purpose of reaching to the destination. So what is the difference between circuit switching and packet switching? In circuit switching, all the packets will be transmitted in the same path or dedicated path, whereas in packet switching, each packet will be moving in its own direction to reach to the destination. Okay, so that is the difference between packet switching and circuit switching. Now, where do we use circuit switching? Generally, voice calls, okay, uses circuit switching. When do we use packet switching? Packet switching is used, packet switching is used in normal, like WhatsApp message, direct message, etc. And lastly, we have message switching. So what do you mean by message switching? Here, again, I want to transmit the data from A to B. Okay, here, I will not divide the data. As if you see in circuit switching and packet switching, I divided the data into packets. Here in message switching, we will not divide the data into packets. Okay, once the sender says send, the data will be transmitted to the first switch. Okay, and this switch will store the data. Now once the path is available, let us say, okay, it will wait till the path is available. Once the path is available, it will forward this particular entire data to the next switch. Again, the switch will store the data. Now, once again the path is available, okay, then it will transmit the data to the next switch. Okay, so this is how the entire data will be transmitted from one point to another point. Now, this type of transmission is called as message switching, and message switching is also called as store and forward. Okay, it is again an frequently asked question. What do you mean by store and forward? What do you mean by store and forward? It is nothing but message switching, where the entire data will be transmitted from one switch to another switch. A switch will store the data. Once the path is available, it will forward the data to the next switch. Okay, so this is about switched networks. Okay, so with this we have completed network or telecommunication network techniques, or transmission techniques. Okay, so let us move to the next concept: components of telecommunication network. Okay, so how many components we have, sir? Okay, so basically in the initial we studied only the basic components. Now we'll study in detail. So how many components of telecommunication networks we have? We have, okay, 5 components. First one is terminal, which we have already studied. So what do you mean by terminal? Terminal is nothing but a starting or ending point of a telecommunication network. Okay, so we have already studied this particular, okay, terminal definition. Okay, now we have second one called as telecommunication processors. Okay, so what do you mean by telecommunication processor? It is nothing but an hardware device which supports transmission of data between sender and receiver. We have around 10 that we'll see. Okay, so next one we have telecommunication medium. Now this telecommunication medium is classified into two types. First one is guided medium, second is unguided medium. For the guided medium is classified into 3 types, whereas unguided medium is classified into 5 types. Okay, next one we have telecommunication software, and last one is computer. Okay, or it is also called as end user. So how many components of telecommunication networks we have? We have 5 components. First one is terminal, second one is telecommunication processor, third one is telecommunication medium, fourth one is telecommunication software, and fifth one is computer or end user. So already we are done with okay, first one. So what is first one? First one is nothing but terminal. So what do you mean by terminal? Terminal is nothing but it's a starting or ending point of a telecommunication network. Now let us go to the second component. Okay, so first component which we are already done. So what do you mean by terminal? Terminal is nothing but a starting or ending point of a telecommunication network. So this terminal is also called as, okay, these terminals are also divided into 2 types, intelligent terminal or a dumb terminal. So what do you mean by intelligent terminal? A device which consists of a processor is called as an intelligent terminal. What do you mean by dumb terminal? A device which does not have an processor is called as a dumb terminal. Okay. So this is about terminal. Now let us move to the second component, telecommunication processors. Now these are called as hardware resources. Okay. Now why do we require this telecommunication processor? For the purpose of transmitting the data between sender and receiver. Okay. So these are nothing but hardware. What do you mean by hardware? Any component, any physical component which we can touch is called as an hardware. Okay. So this particular telecommunication processors, okay, so first one is called as NIC. What do you mean by NIC? NIC is nothing but network interface card. Okay, so if you see this particular network interface card, okay, so let us see the diagram. So first component is NIC. So what do you mean by NIC? NIC is nothing but a place where you connect a computer to a computer network. Okay, it is simple. Okay, what do you mean by NIC? Like where you connect your internet wire to a laptop. Okay, it is called as an NIC. Okay, so NIC is nothing but a place where you connect a computer to a computer network. Okay, so once you connect internet wire, what will happen? Okay, your personal computer will be connected to network. Okay, so the place where you connect a wire to a computer, that place is called as NIC. Okay, it consists of a buffer for the purpose of storing the data temporarily. Okay, so what do you mean by NIC? NIC is nothing but which connects a computer into a computer network. Second one is called as modem. So what do you mean by modem? Modem is nothing but, okay, which converts analog signal to digital and digital signal to analog signal. Okay, so modems are required for the purpose of, okay, converting. This is a symbol for analog. Okay, so what do you mean by analog signal? A signal which is understood by a wire, physical wire, copper wire, is called as analog signal. A signal which is understood by a computer is called as a digital signal. Okay, so what do you mean by from, okay, digital signal to analog signal? Okay, so that is called as modem. Next one is called as a multiplexer. So what do you mean by multiplexer? Multiplexer is nothing but you have multiple devices. Okay, like here 4, here 4. Okay, now if these 8 devices shares a common or a single transmission medium, that is called as multiplexer. So what do you mean by multiplexer? If multiple devices shares a single transmission medium, okay, and at one place, now let us say these 4 devices A, B, C, D is transmitting the data. So at one end it merges the data, at other end it separates the data. That is called as a multiplexer. Okay, so what do you mean by multiplexer? Multiplexer is nothing but, okay, which shares a common communication medium. At one end it merges the data, at other end, okay, it separates the data. Next one. So we are done with 3 devices. First one is NIC. NIC is nothing but which connects a computer into a computer network. What do you mean by modem? Modem is nothing but which takes an analog signal, which converts analog signal into digital signal. Next one is multiplexer. Multiplexer is nothing but you have multiple devices, okay, which will be sharing a common communication medium. At one end it merges the data, at other end it separates the data. Let us move move to the next device. Exactly is a repeater. Repeater is nothing but, okay, it takes a weak signal, okay, and it will amplify the signal. Amplification is nothing but enlarging the signal, okay. Repeater will amplify the signal so that from one section of cable, it will be, okay, enlarged or amplified. Like it is just like a mic, okay. So what exactly mic will do? Mic will amplify your voice, okay. So that the same thing, a repeater will amplify the signal, analog signal. This symbol is analog signal, okay. A repeater will amplify the signal so that the data will be transmitted from one section of cable to other section of cable. Next one is called as bridge. So what do you mean by bridge? Bridge is nothing but, okay, which connects one or more LANs together. LAN 1, LAN 2. We already studied LAN. What do you mean by LAN? LAN is nothing but local area network, okay. So bridges are required for the purpose of, okay, connecting number of LANs together. Not only that, it also performs amplification of data, okay. So repeater and bridge both performs amplification of data, but bridge also connects different number of LANs together. Now, what do you mean by router? Router is nothing but which works under different protocols, okay. So we already studied protocol. What do you mean by protocol? Protocol is nothing but, okay, protocol is nothing but it's a common set of rules which are agreed by both the sender and receiver, okay. Next, hub. Hub is nothing but port switching telecommunication network, which we already studied in, okay, peer-to-peer networks, okay. So what do you mean by hub? Hub is nothing but a port switching telecommunication network where you can connect multiple devices for the purpose of sharing the data, okay. So this is nothing but ports, okay. What do you mean by port? A port is nothing but a place where you connect a computer, okay, to the network is called as a port, okay. So hub is nothing but a port switching telecommunication network where you can share the data. Next one is called as switch. What do you mean by switch? Switch is nothing but it's a okay, it is required for the purpose of connecting telecommunication circuit, okay. So we studied packet switching, message switching, etc. What exactly is that particular network? That network is nothing but a telecommunication circuit. So if you want to connect different telecommunication circuits, then we need to use a switch, okay. Last one is called as a gateway. So what do you mean by gateway? Gateway is nothing but which connects different telecommunication architectures, okay. Like if you want to connect Idea, Vodafone, okay, MTS, Jio, BSNL, etc., you need to use gateway. If the gateway is not there, what will happen? Idea person will talk to Idea person, Vodafone will talk to Vodafone, BSNL will talk to BSNL only. That means you need to maintain multiple SIMs, okay. But if at all you have a gateway, so gateway will connect to different telecommunication architectures, okay, so that heterogeneous networks can be made, okay. So this is about the devices which we have in telecommunication processors, okay. So these are devices and it's very, very important devices, okay. Let us move to the third, okay, component. Third component is about telecommunication medium. Again, this telecommunication medium is classified into two types. First one is called as a guided medium. Second is called as unguided medium. Simple. Guided medium is nothing but if at all you are using a wire, it is called as a guided medium. What do you mean by unguided medium? If at all you are not using any wire, okay, wireless transmission is called as unguided medium, okay. Now this guided medium is further divided into three types. First one is called as twisted pair. Second is called as coaxial cable. Third one is called as optical fiber cable, okay. So what do you mean by twisted pair? Basically, twisted pair is nothing but an ordinary telephone wire, okay. So earlier, okay, so before we go to this particular guided medium, you need to understand a basic concept. Like we have a concept called as materials. Materials are classified into two types. First one is called as a conducting material. Second is called as a non-conducting material, okay. So what do you mean by conducting material? Conducting material passes electricity. Non-conducting material doesn't pass an electricity, okay. So if you see these particular twisted pairs or guided medium, okay, these are conducting material. So that means which passes an electricity, okay. So what do you mean by twisted pair? Twisted pair is nothing but, okay, which uses an ordinary telephone wire. And what is the material we use? We use a material called as copper, okay. So what is a copper? Copper is nothing but a conducting material through which the data will be transmitted, okay. So it supports both the transmission of data and voice. However, it has an electrical inference, okay. So what do you mean by electrical inference? For example, let us say this is a copper wire, okay. So how the data will be transmitted? Data will be transmitted in an analog format, okay. In an analog format, the data will be transmitted, okay. Now, if other electrical signal, outside electrical signal, okay, is entering to this particular, okay, or, okay, passing through this particular, okay, wire, what will happen? It creates a disturbance or it creates a noise, okay. So that is called as an electrical inference, okay. It's a simple concept. Like let us say if at all you put your mobile near to your TV, and if you call to that particular mobile, the signal on the TV will, okay, blurred. Okay, so why that happens? Because of the electrical inference. Okay, that means your mobile signal is disturbing the TV signal, then then a noise will be created. Okay, so that is called as a twisted pair. So next one is called as a coaxial cable. Okay, so coaxial cable is nothing but a cable wire. Okay, if you have seen your television cable wire, it will be very thick. Okay, now that particular cable wire will have a black color material. If you remove that black color material, you have a silver foil. Okay, so if you remove that silver foil also, you have a very hard plastic material, which will be very hard plastic material. Okay, now if you remove that particular plastic material with a cutting pair, if you cut it, okay, then inside that particular plastic material, you'll be having either a copper wire or an aluminum wire. Okay, now why do we require that hard? If you see this, okay, this is how it will be. Okay, it consists of a thick plastic material. Inside you have a copper or an aluminum wire. So this is how the data will be transmitted. Okay, now if other electrical signal is coming, okay, so whether it can pass through this plastic material? No, because plastic is nothing but a non-conducting material. That means it doesn't pass electricity. So this particular outside signal cannot pass through this particular okay, plastic material. So it will not disturb the signal which is transmitted inside. Okay, so it has a very low electrical inference. However, it is little bit costly compared to a twisted pair. Okay, now after that we have an optical fiber cable. So optical fiber cable, how do we do it? Okay, the thickness of this particular optical fiber cable is very thin. Okay, if you take one hair, okay, the diameter of one hair is called as an optical fiber. Okay, so very thin. However, for a purpose of understanding, I have extended little bit. So you have, okay, material, glass coating material, outside and down, upside and downside. So the uniqueness of this particular optical fiber cable is it supports both analog and digital signal, whereas a twisted pair and coaxial cable supports only analog signal. So if you see this particular optical fiber cable, it supports both analog and digital signal. So using we convert this analog signal and digital signal into light using a laser beam. Okay, we hit this particular light to glass. Okay, when light hits glass, what happens? It reflects. Okay, again it reflects, again it reflects. Okay, so this is how the transmission happens. Okay, now even if an outside electrical signal, if at all it is coming, can it pass through glass? No, because glass is a non-conducting material. Okay, so this is about guided medium. Okay, so we have unguided medium. Okay, so let us take a break for 10 minutes and after that we'll continue. Break తీసుకున్నామా? హలో, బ్రేక్ తీసుకున్నామా? బ్రేక్ తీసుకున్నాం. So we started guided medium. So we completed, okay. So we are studying the third component. What is the third component? Telecommunication medium. So telecommunication medium is divided into how many types? It is divided into two types. First one is called as guided medium. Second is called as unguided medium. So guided medium is further classified into how many types? Three types. First one is called as twisted pair. Second is coaxial cable. Third one is optical fiber cable. Okay. So we are done with the guided medium. Now let us move to unguided medium. So unguided medium is further classified into five types. Okay, so what do you mean by unguided medium? Unguided medium is nothing but where you will not have a physical wire for the purpose of transmission of data. Okay, so first one is called as terrestrial microwave. This terrestrial microwave is also called as, okay, earthbound microwave. Okay, this is also called as earthbound microwave. Why this particular terrestrial microwave is also called as earthbound microwave? Because these particular antennas will be present on the surface of the earth. Okay, if you take this particular thing as a surface of earth, on the surface of the earth, okay, if you have antennas, and how the data will be transmitted, it uses air as a transmission medium. It uses air as a transmission medium for the purpose of transmitting the data. Okay, so this is relay station 1, this is relay station 2. The maximum distance between two relay stations should be 30 miles. Okay, so whether it can transmit data and voice? Yes, it can transmit both data and voice. Okay, so this is about terrestrial microwave. Next one is called as radio wave. What do you mean by radio wave? Radio wave, you need to remember this particular thing. Okay, it can generate a wavelength of 1 mm to 1 lakh kilometer, 1 millimeter to 1 lakh kilometer, and it will be used in wireless LANs. Okay, so what do you mean by wavelength? Wavelength is nothing but the distance between waves, sir. Okay, that's it. Okay, so wavelength is nothing but distance. Okay, distance between this and this. Okay, is called as wavelength. Now, what do you mean by microwave? Microwaves also have a wavelength of 1 meter to 1 millimeter, and it has a frequency of 300 gigahertz to 300 megahertz. Okay, so if you see this particular microwave, okay, again, wavelength is nothing but distance, frequency is nothing but speed. Okay, next one is called as infrared wave. What do you mean by infrared wave? Infrared waves are used for the purpose of okay, watching the objects during the night time. Okay, so it is used in medical, scientific, and industrial applications. Okay, after that we have, okay, next one called as communication satellite. So what do you mean by communication satellite? Is nothing but, okay, a man-made satellite. Okay, so which will be having certain solar panels. Okay, so these are nothing but solar panels. Okay, now why do we require these solar panels? For the purpose of observing the energy, okay, from the sun, for the purpose of generating the electricity, and it uses a technique called as RAR. What do you mean by RAR? Okay, once it receives the data from the earth, okay, it will amplify. A means amplify, receive, amplify, and again it will retransmit to other part of the earth. Okay, so this is how the transmission happens using communication satellite. Okay, so after that, okay, the next component will be, okay, telecommunication software. So what do you mean by telecommunication software? Okay, so we studied telecommunication processors. Okay, so telecommunication processors are nothing but hardware resources where, okay, it supports transmission of data between sender and receiver, whereas telecommunication software manages and controls transmission of data. Okay, so this is a software that is a hardware. So we require both, okay, telecommunication processors and telecommunication software for the purpose of transmission of data. Okay, now it provides around 5 services. First one is called as network management. So what do you mean by network management? Network management provides wide variety of services. Okay, now one of the important service network management provides is connection and disconnection of devices. Okay, so what do you mean by connection and disconnection of devices? Whenever, okay, you transmit the data, okay, so at the time before you transmit the data, like cell phone, okay, So before you talk, okay, when you dial a number and press that green button, it will have a ringing tone, okay. So during that particular ringing tone, what will happen? The devices will get connected. Okay. Now once the connection is established, then the transmission happens. Okay. So network management, one of the basic service it provides is connection and disconnection of devices. Okay. Now once the transmission is completed, once you complete your conversation, you press that red button. So what will happen? There will be a disconnection of devices. Okay. So basically network management provides so many services, a wide variety of services. Okay. One of the service is connection and disconnection of devices. Not only that, this network management monitors 3 parameters. First one is speed. Second one is mode. Third one is direction. Okay. So these are the 3 parameters it will provide. First one is speed. Second is mode. Third one is direction. What do you mean by speed? Okay. Now depending on the speed only, we need to determine whether to transmit the data in asynchronous transmission or synchronous transmission. Now, depending on the mode, okay, we need to decide whether to transmit in simplex, half duplex or full duplex. Depending on the direction, okay, so we need direction for the purpose of transmitting the packets to the recipient. So these are the 3 parameters which a network management will monitor. And also it provides another service called as a traffic management. Now what do you mean by traffic management? Traffic management is nothing but it controls network resources. Okay, what do you mean by network resources? Okay, you have 10 telecommunication processors, right? Okay, so those network resources will be managed by traffic management because those are the hardware resources. Those should be managed and controlled. Now who will control it? There's a component called as traffic management which will control it, and also which will avoid traffic congestion. What do you mean by traffic congestion? Okay, it will not allow the packets to jam. Okay, so when multiple senders and receivers are transmitting the data, it may so happen where the packets may get jammed. Okay, so this particular component will avoid the traffic jam or traffic congestion. Next one is called as security. Okay, it provides security by 4 aspects. Okay, first one is called as authentication. Authentication is nothing but verifying. Okay, so without verifying, it will not transmit the data. Second is called as encryption, which we have already studied. Encryption is nothing but conversion of a plain text to ciphertext is called as encryption. Now security policies. Okay, now what do you mean by security policies? Security policies are nothing but like implementation of antivirus software is a security policy. Implementation of a firewall is a security policy. That means throughout the organization, you need to implement these type of things. Okay, and last one is called as audit functions. What do you mean by audit functions? It is nothing but what is the usage of resources? Okay, who used which resource, etc. All these particular things will be tracked using an audit trail. Okay, we'll study in chapter 4. Okay, we have a concept called as audit trail. Okay, using audit trail, we can able to monitor or track the users what exactly they are using the resources. For example, if at all you are using the printer daily to print 1,000 pages, okay. Now what happens under your name, username so and so, username Sandeep, okay, he logged into system at 10 o'clock. He started using printer at 10:30. He used printer up to 2:30. Okay, how many pages printed? 1,000 pages printed. Okay, so everything, whatever you do on the networks will be monitored using an concept called as audit trail. Now, why do we require audit trail? For the purpose of doing audit functions. Okay, what are audit functions? Audit functions are nothing but consumption of resources. Who used which resource at what extent? That will be monitored using audit trail. Next one. Next one is called as network monitoring. What do you mean by network monitoring? Network monitoring is nothing but troubleshooting. What do you mean by troubleshooting? If at all you have any errors, which can be rectified using network monitoring, and also if at all you have any potential threats, that also can be eliminated. Okay, prevented. Okay, so it is just like a security guard. Okay. Next is capacity planning. Capacity planning is nothing but surveying network resources. Okay. Now, depending on the traffic patterns, okay, if at all you are allocating the resources, that is called as capacity planning. A simple example, like let us say if at all you take Panjagutta Junction. Okay. Now, in Panjagutta Junction at 5 o'clock, do we have a traffic? No. Okay. So, do we require a traffic constable? Not required. Okay. So, let us say at 8 o'clock. Okay. Do we have a traffic? Yes, we have a mild traffic. Do we require traffic constable? One traffic constable is enough. Okay. At 10 o'clock, the traffic will be at peaks. One traffic constable is not required. So what do? We allocate 4, 5 depending on the traffic. Okay. So what exactly we are doing? We are studying the traffic. Depending on the traffic, we are allocating the resources. The same way in the networks also, networks will survey the traffic patterns. Depending on the traffic patterns, it will allocate the resources. So these are 5 components of telecommunication networks. Okay, so with this we have completed Okay, sorry, we have completed 4. Okay, the last one is an end user. Okay, which is nothing but, okay, any person who is using an information system is called as an end user. Okay, so these are the components of telecommunication networks which we have studied. Okay, so we started with terminal, we completed telecommunication processor, we completed all the devices, we started telecommunication medium. We have two types of telecommunication medium, guided and unguided. Okay, in guided we have 3, unguided we have 5. Okay, telecommunication software we have completed, and last one, computer or end user. So these are 5 components of telecommunication network. With this we are done with almost part A is completed. So we have a small topic called as protocols. So what do you mean by protocol? Protocol is nothing but the softwares. Okay, so protocols are nothing but softwares which provide variety of actions. Okay, and also one more definition is it consists of set of rules which are agreed by both the sender and receiver. Okay, we have 3 digital aspects. This particular question, please read, okay, by yourself. Okay, we have 3 digital aspects. First one is syntax, semantics, and timing. So you please cope up, okay, with these aspects of protocols. Okay, I'm leaving this, and types of protocols also I'm leaving. Okay, so these types of protocols, etc. Okay, so with this we have completed part A, and part B is about network security, like what is a firewall and all that particular aspect that you can, okay, study, okay, on your own. Okay, internet, intranet, extranet, etc. that you can study on your own. Okay, so let us go to, okay, so we are done with, okay, almost 70% of, okay, almost we have completed 70% of chapter A. Now, okay, let us start, okay, another chapter. So let us start with chapter 4. So 1 minute, okay, so let me take the file. Okay, 1 minute, I'll start. Let me share the screen. Okay. Okay, so let us start. Okay, so basically what we have studied in chapter 3 is about telecommunication networks. So what do you mean by telecommunication Telecommunication networks. It's nothing but, okay, how do we transmit the data from one location to another location? And how do we transmit? What are the methods? All the things which we have completed in chapter 3. Okay. Now in chapter 4, okay, we'll study about information systems. Okay. So why do we require information systems? What do you mean by information systems? Okay. So information system is nothing but a software. Okay. So which type of software it is? It is nothing but an application software. Okay. So what do you mean by application software? Any software which is used by the user, okay, is called as an application software. Okay. So if at all you want to perform this task, okay, at that time, okay, you can use this particular information system to perform a user's task. Okay. Now, basically, why do we require information systems? Information systems are required for the purpose of automation. Okay. So if you want to automate anything, okay, you need information systems. Okay. Now, let us start with the definition of information systems. So what do you mean by information system? Information system is nothing but it's a combination of people. So who are people? The person who uses an information system and the person who develops an information system is considered as people. Okay. So what do you mean information system? It's a combination of people, hardware. Okay. Hardwares are nothing but any physical component. It's a combination of software, telecommunication network, communication devices, storage devices, and other resources. So what do? We take the data, okay, and okay, using this particular data, if you send this particular data through these particular components, will be converted into information. And how the information is presented? Information is presented by way of a report, so that, okay, a business executive can analyze the data and he can take a business decision. So this is a standard definition of information system. So what do you mean by information system? Information system is nothing but a combination of people, hardware, software, telecommunication networks, communication devices, storage devices, and other resources. Now, what does it do? It converts, okay, it converts data into information, and this information is presented by way of report, so that a business executive can analyze this particular data to take a business decision. Okay, so this is about this is a standard definition of information systems. Okay. Sorry. This is standard definition of information system. Now let us move to the next one, types of information systems. Okay. So basically, how many types of information systems we have? We have 4 levels of information systems. Okay. Generally, an organization will be of 3 levels. Like you have an operation level, you have a middle level, and you have a top level. Okay. The same way, information systems are also classified into, okay, 3, and you have additional level called as a knowledge level information systems. So basically, total 4. Okay. So strategical level information systems are used by top level management. Management level information systems are used by, okay, middle level management, and operational level information systems are used by low level management. Okay. Knowledge level information systems are used by knowledge managers. Okay. That's called as a knowledge level information system. Okay. It's an additional information system. Okay. So in this particular chapter, in chapter 4, I cover chapter 2 as well, okay, because we have 2 important concepts, that is SDLC and layers of information systems. Okay, those two topics also will be covered in chapter 4 itself. Will not be taking chapter 2 separately. So those 2 important topics, okay, will be covered here only. Okay, layers of information systems and SDLC. Okay, and next one, okay, we have few topics in chapter 2, that is cloud computing, and we have certain topics of BPA that will be covered in chapter 5. So basically, we'll not be having a separate chapter 2 session. It will be included in chapter 4 and chapter 5 itself. Okay, so that means once I complete chapter 4, that means chapter 4 is done and chapter 3 is done. So basically, okay, we'll be completing, by the end of this chapter 4, we'll be completing 3 chapters. Okay. So how many levels, how many type of information systems we have? We have, okay, 4 types of information system. First one is called as a strategical level information system. Okay. Second one is management level information system. Third one is knowledge level information system, and last one is operation level information systems. Okay. Now let us start with Okay, first one, that is TPS. Okay, now TPS is nothing but an operational level information system. What is TPS? TPS is nothing but an operational level information system. Okay, it's an operational level information system. So who will use operational level information system? The low level management will use an operational level information system. Now when you call TPS, okay, it has to satisfy, okay, these four characteristics. Okay, so what are the characteristics it supports? Okay, it should collect the data, it should store the data, it should modify the data, and it should retrieve the data. Okay, so that particular information system which collects the data, stores the data, modify and retrieve the day-to-day transaction, that type of information system is called as an TPS. So what is an example for TPS? Railway reservation system, banking system, etc. are examples of TPS. So this is about operational level information system, TPS. So what do you mean by TPS? TPS is nothing but and low level information system which is required for the purpose of collecting, storing, modifying and retrieving day-to-day transactions. Okay. Next one. So you have few topics in TPS itself. We'll study one after other. Okay. Now we have 4 stages in TPS. How many stages we have? We have 4 stages in TPS. First one is called as data entry. Second is transaction processing. Third one is database maintenance. Fourth one is report generation. So these are the 4 stages we have in TPS. So what are the 4 stages? First one is data entry. Second is transaction processing. Third one is database maintenance. And last one is report generation. So what do you mean by data entry? Data entry is nothing but capturing business data. Okay. So how do we capture business data? That is called as data entry. Okay. Now, how do we capture the data? So we have 2 methods, either by way of a keyboard. Okay. If you want to enter the data, how do you enter the data into the system? By using a keyboard, or by using an optical scanner. Okay. So what do you mean by optical scanner? If you go to Big Bazaar, etc. Okay. They have an optical scanner. Sorry. They have an optical scanner. So what do? They take a product and scan the barcode, okay, using that optical scanner, and all the details of the product will be captured on the monitor. So this is called as data entry. So what do you mean by data entry? Data entry is nothing but capturing of business data. Plus transaction processing. What do you mean by processing? Processing is nothing but conversion of data into information. And how many ways we can convert it? We have 2 ways. First one is called as batch processing. Second is called as online processing. So what do you mean by batch processing? Batch processing is nothing but if a transaction is delayed for some time. Okay. So if a transaction is delayed for some time, it is called as batch processing. A perfect example is NEFT, N-E-F-T. Okay. So once you initiate a transaction, immediately the transaction will not be completed. It takes certain time for completion of a transaction. So that is called as batch processing. So second is called as online processing. What do you mean by online processing? Online processing is nothing but if a transaction is completed immediately, that means once you initiate a transaction, if the recording is also done, then that type of transaction is called as online transaction. Okay. So best example for this online transaction is IMPS transactions. Okay. Next is database maintenance. So what do you mean by database maintenance? Database maintenance are required for the purpose of storing and retrieving data, or storing up-to-date data, for processing. And last one is report generation. Report generation is nothing but this component generates variety of reports. Okay. So these are 4 stages in TPS. First one is data entry, second is transaction processing, third one is database maintenance, and last one is report generation. Okay. After that, we have TPS attributes. So how many attributes we have? We have 4 attributes. First one is access control. Second is equivalent to TPS. Third one is high speed, high volume TPS. And last one is trustworthy TPS. Okay. So how many attributes we have? We have, 4 attributes. First one is called as access control. Second is equivalent TPS. Third one is high speed, high volume TPS. Last one is trustworthy TPS. What do you mean by access control? Okay. Access control is nothing but putting a ceiling on the user. Okay. So what do you mean by putting a ceiling on the user? People who are not authorized, are not permitted to do a transaction. That is called as access control. So what do you mean by access control? So putting a ceiling to the user, it is nothing but if at all you are authorized, then you are permitted to do a transaction. If at all you are not authorized, you will not be permitted to do an transaction. That is called as an access control. A perfect example for this particular access control is, like, let us say if at all you have a bank, okay, information system. Now let us assume we have three roles. First one is teller, second is manager, third one is branch manager. Okay, so a teller can do debit and credit. Okay, so what is his scope? Okay, he is permitted to do a debit and credit. It is nothing but deposit and withdraw. Okay, a manager can do debit and credit, and also he can modify the data. What do you mean by modification of data? Modification of data is nothing but if the teller commits any mistake, okay, that mistake will be rectified by the manager. Okay, so that is called as modification. Okay, so branch manager can do debit credit, he can modify the data, and also he can open a new account. Okay, so each and every role will be having a set of actions which they can perform. Okay, for example, teller can do debit and credit. Now, if at all he is trying to modify the data, the information systems will tell, okay, you are not authorized to do this particular transaction. Okay, because of access control. What do you mean by access control? Access control is nothing but putting a ceiling to the user is called as access control. Second is called as equivalent TPS. What do you mean by equivalent TPS? The data is always collected in a similar formats. Okay, so what do you mean by similar formats? Similar formats is nothing but, okay, if you take IRCTC website, okay, at the time of booking ticket, okay, the data, okay, where you enter, the format of the data where you enter will be same for you. Even at the ticket, so interfaces will be designed in such a way. So always they have a similar formats. Why do we maintain similar formats? For the purpose of achieving the effectiveness. Okay. Next one is called as high speed, high volume TPS. Now, what do you mean by high speed, high volume TPS? It is nothing but every transaction has to be completed immediately and the data has to be sent to other person at the same time. Okay. For example, okay, what do you mean by high speed? Every transaction has to be completed immediately. Okay. And the data has to be sent to other person at the same time. For example, if I book an Ola, okay, so a confirmation message has to receive to me, okay, and also it has to be received by the driver. Okay. So if the driver doesn't receive the message or me doesn't receive the message, then the transaction is called as an incomplete transaction. Okay, so every transaction has to be completed very fastly. At the same time, the data has to be sent to other person immediately. Okay, last one is called as trustworthy TPS. What do you mean by trustworthy TPS? It is nothing but every TPS should be a robust one. Okay, robust one, and okay, it has to do the transaction very fastly, and at the same time it has to follow certain rules. Okay, so what are the rules that we'll see in the next topic? Okay, so these are 4 attributes of TPS. What are the 4 attributes of TPS? First one is called as access control. Second is called as equivalent TPS. Third one is high speed, high volume TPS, and last one is trustworthy TPS. Okay, now let us move to the next topic. Okay, in TPS only we have TPS acid properties. Okay, so what do you mean by acid properties? Acid means A means atomicity, C means consistency, I means isolation, D means durability. Okay, so what do you mean by atomicity? Atomicity is nothing but, okay, the transaction either it has to be completed wholly or not at all. Okay, so what do you mean by atomicity? Either the transaction has to be completed wholly or not at all. For example, if I am transferring, okay, certain money from account A to account B, it should be 2 events, okay, debit and credit. Okay, so let us assume if debit is completed, credit is not completed, can I call it as a valid transaction? No, it is not a valid transaction. It's an invalid. So if at all debit is not completed, credit completed, okay, then can I call it as an valid transaction? No, it is an invalid transaction. Now debit completed, credit completed, can I call it as an valid transaction? Yes, it is called as a valid transaction. Okay, so that is called as atomicity. What do you mean by atomicity? Either the transaction has to be completed wholly or not at all. Okay. After that, we have consistency. What do you mean by consistency? Okay, every transaction has to follow certain rules or conditions. Okay, so every transaction has to follow certain rules or conditions. For example, if I want to transfer rupees 30,000 from account A to account B, however, account A is having a balance of 20,000. Now, it should not transfer 30,000 from account A to account B. Before it starts this particular transaction, it has to check whether account A is having sufficient balance or not. Okay, so that is called as, okay, checking of a rule or operating rules. Okay, so this is called as consistency. Next one is isolation. What do you mean by isolation? Every transaction has to be performed in isolation. However, it should appear as if the transaction is happening simultaneously. For example, so if I am transferring certain money from account A to account B, okay, from the system's point of view, debit happens first, then credit. Okay. However, it should appear to the user as if both debit and credit is happening simultaneously. Okay. So that is called as isolation. And last one is called as durability. What do you mean by durability? Durability is nothing but once a transaction is completed, it cannot be undone. So these are 4 properties of TPS. Okay, first one is called as A. A means atomicity. Second one is called as C. C means consistency. Third one is I, isolation, and last one is durability. Okay, so these are 4 acid properties. So we started with TPS. We studied what is the definition of TPS. We studied what are the stages in TPS, what are the attributes in TPS. So we are done with TPS definition, we are done with stages in TPS, attributes in TPS, and TPS properties. Okay, so these are topics in TPS. Now let us go to the knowledge management information system. So knowledge management information system is nothing but these information systems are required storing the knowledge, retrieving the knowledge, and locating the knowledge. Okay, it improves collaboration and performs data mining. Okay, so what do you mean by knowledge? Knowledge is nothing but, so there is a difference between data, information, and knowledge. What do you mean by data? Data is nothing but raw facts is called as data. What do you mean by information? Information is nothing but processed data is called as information. So what do you mean by knowledge? Knowledge is nothing but an experience, is called as knowledge. Okay, so why do we require knowledge management systems? Knowledge management systems are required for the purpose of storing, retrieving, and locating knowledge. It improves collaboration. What do you mean by collaboration? Collaboration is nothing but communication between the employees. Okay, so it also performs data mining. So what do you mean by data mining? Data mining is nothing but where the volume of data is very huge at that time. What do we do? Okay, we try to find out a hidden pattern in large volumes of data. Okay, so that is called as data mining. Okay, now it supports 2 types of knowledge. First one is called as an explicit knowledge, tacit knowledge. Okay, so it supports 2 types of knowledge. First one is called as knowledge. Second is called as any knowledge which can be converted into a document is called as explicit knowledge. Okay, for example, English grammar is an explicit knowledge. Okay, simple. Any knowledge which can be converted into a document is called as explicit knowledge. What do you mean by tacit knowledge? Any knowledge which cannot be converted into a document is called as tacit knowledge. Okay, like common sense. Okay, or experience. Okay, or let us say belief, customs. Okay, these judgmental power, etc. All these particular things are tacit knowledge. So knowledge is converted into how many types? 2 types. First one is called as an explicit knowledge. Second is called as a tacit knowledge. Okay. So what do you mean by explicit knowledge? A knowledge which can be converted into a document is called as an explicit knowledge. What do you mean by tacit knowledge? Any knowledge which cannot knowledge. Okay. So we completed operation level information systems. Okay. We are studying knowledge level information systems. In knowledge level information systems, we understood what is a knowledge, and we have completed knowledge management system. Okay, we have completed knowledge management system. Now we have one more called as decision support systems. Okay. So what do you mean by decision support systems? Decision support systems are nothing but an information systems which are required, which will provide the solutions to the user. Okay, that means when a user gives a problem, now this problem will be solved by the decision support system to give a solution or appropriate solution. However, the uniqueness of decision support system is it gives appropriate solution. Now, it is the responsibility of the manager to select the final answer. Okay. Now, where do we use these decision support systems? These decision support systems are used for the purpose of solving capital budgeting problems. Okay, ratio analysis. Okay, which will be used in investment portfolios, etc. Okay. Now, let us see the components of decision support systems. Decision support systems consists of 4 components. First one is user interface. Second is databases. Okay. Third one is planning languages. Fourth one is model. Okay. So these are the 4 components. Okay. A decision support system will be having. So what is the first component? User interface. What is the second component? Databases. Third component is planning languages. Fourth component is model. Okay. So what do you mean by user interfaces? Using these particular user interfaces, we interact with the decision support system. Now, without user interface, can I interact with the decision support system? It is not possible. So, decision support systems are, user interface is required to interact with the decision support systems. Now, who will use decision support systems? Experts will use decision support systems. Okay. Now, who are experts? Manager, accountants, auditors are called as experts. Okay. Now, for what purpose they use these decision support systems? Decision support systems are used for the purpose of solving semi-structured and unstructured problems. Okay. So, what do you mean by semi-structured, unstructured? Okay. In information technology, we divide the entire problems into three categories. First one is called as a structured. Second is semi-structured. Third one is unstructured. Okay. Now, what do you mean by structured problems? A structured problem can be always automated. Okay, from one end to other end. Okay, we can entirely automate from one end to other end. That type of automation is called as a structured. What do you mean by semi-structured? Semi-structured is nothing but 1 minute. Okay, getting a call. Let me attend. 1 minute. User interface which we are done. Okay, so what is the second one? Second one is called as planning languages. So second is called as planning languages. How many types of planning languages we have? We have two types of planning language. First one is called as a general purpose planning language. Second is called as special purpose planning language. Okay. So what do you mean by general purpose planning language? These planning languages are required for the purpose of doing, okay, small analysis, okay, small arithmetical analysis. Okay, so these general purpose planning languages are required for the purpose of doing small analysis or arithmetical calculation. Okay, whereas a special purpose planning languages are required for the purpose of, okay, analyzing huge volume of data. For example, let us say I want to do the analysis of, okay, of the entire population of India, where I want to know how many people are having BMW car. Okay, so at that time I cannot use a general purpose planning language. I have to use a special purpose planning language. Okay, so planning languages are of two types: general purpose and special purpose. Okay, so what do you mean by general purpose? General purpose planning languages are required for the purpose of doing small analysis of data and arithmetical calculations, whereas a special purpose planning languages are required for the purpose of analyzing huge volume of data. Third one is databases. Why do we require databases? Databases are required for the purpose of storing and retrieving. And how many types of data it will store? It stores 4 types of data: internal, external, routine and non-routine data. So what do you mean by internal data? Internal data is nothing but the data which is generated What do you mean by internal data? Internal data is nothing but the data which is generated within an organization is called as internal data. So for example, okay, okay, so what do you mean by internal data? Any data which is generated within an organization is called as internal data, like sales data, expense data, okay, etc. What do you mean by external data? External data is nothing but the data which is generated outside an organization is called as an external data. Okay. So what do you mean by external data? Like let us say bank interest rate, okay, reverse repo rate and reverse repo rate. All these particular things are called as external data. So what do you mean by routine data? Routine data is nothing but, okay, day-to-day transaction data is called as routine data. What do you mean by non-routine data? Non-routine data is nothing but seasonal data is called as non-routine data. What do you mean by seasonal data? Like let us say if at all the sales happens during festival season, okay, like 1, 2, 3 days, okay, the number of transactions during the 3 days will be high. So that is called as a non-routine data, okay. And last component is called as a model. Now, what do you mean by model? Model is considered as brain of a decision support systems, which is required for the purpose of doing manipulations and calculations. And this model will provide appropriate solutions. Okay, it will provide appropriate solutions. Okay. So this is about decision support systems. Decision support systems are basically required for the purpose of solving solving the business problems. Okay. So this is about knowledge management information systems. So we are studying different levels of information systems. We are done with the operation level information system. Operation level information system example is operation level information system example is TPS. We completed knowledge level information system. Knowledge level information system example is knowledge management system and decision support system. Now let us move to the third level. Third level is management level information system. It's a small topic. Okay. So management level information systems are used by middle level managers. So who will use this management level information systems? Management level information systems are used by middle level managers. Okay. Now these particular MIS consists of a specialized hardware, a specialized software and data. Now, this of specialized software and data, which provides timely, accurate and updated data to the middle levels. Okay. So these middle level managers using this data. So what do you mean by timely data? Timely data is nothing but whenever the user is requesting, immediately it will allocate the data. What do you mean by accurate data? Accurate data is nothing but the data without any errors. What do you mean by up-to-date data? Up-to-date data is nothing but at this particular point of time, what data is there, that data is called as up-to-date data. And these middle level managers will generate a report called as regular reports for the purpose of doing planning, analysis and taking decisions. Okay. So ask and true or false. Okay. Whether management level information systems are used for the purpose of generating tailor-made reports. The answer is no. Okay, it is only used for the purpose of generating regular reports. Okay, so from where it will get the data? Okay, the output of TPS will become an input to MIS. Okay, so all the output of TPS will become an input to MIS, and always it will provide only pre-selected data. What do you mean by pre-selected data? Now let us say if at all he is a sales manager, it will allow him to see only sales related data. If at all he is an inventory manager, it will allow him to see inventory related data. Okay, so that is called as management level information systems. Okay, so we are done with third level, that is management level information systems, and let us see the last level. Last level is executive information system. So what do you mean by executive information system? Now these particular information systems are used by top level management. Now the uniqueness of this particular information system is it combines both internal data and external data. What do you mean by internal data? Internal data is nothing but data generated within an organization. It combines internal data with external data and it converts this particular data into a condensed view or a graphical view. Okay, so what do you mean by condensed view or a graphical view? It is nothing but it converts the data into a pie diagram or a bar diagram, so that the top level management can analyze the data very easily. Okay, so this is executive level information system, and we have 4 components: hardware, software, and hardware, software, user interface and telecommunication networks. Okay, so these are 4 components of executive level information system. So with this we are done with different levels of information systems. So how many levels of information systems we have? 4 levels: strategical level information system, management level information system, knowledge level information system, and last one we have first one we have strategical level, management level, knowledge level and operation level. Okay, so we have next topic called as importance of access and privilege controls. So importance of access and privilege controls, we have a concept called as access controls. So how do you implement access controls? By way of identity management. So what do you mean by identity management? Now here we need to use 2 terms, subject and object. So what do you mean by subject? A user is called as a subject. What do you mean by object? It is nothing but any network resources is called as object. Okay. So if the subject, okay, is attempting to access an object, okay, now before the subject is entered into object space, if the verification is done, then it is called as identity management. Okay. So what do you mean by identity management? Identity management is nothing but, okay, if a subject who is attempting to access an object, before a subject enters into object space, if the verification happens using user ID and password, then it is called as identity management. Okay. So the words attempting, verifying the identity is very, very important. Now, does it provide 100% security? No, it does not provide 100% security. It only provides probability of security. Okay. Now, as it doesn't provide 100% security, we require three pillars of identity management. First one is called as authentication. Second is authorization. Third one is called as accountability. So these are three pillars of identity management. So what is the first one? First one is called as authentication. Second is authorization. Third one is accountability. So what do you mean by authentication? Authentication is nothing but verifying the subject at the point of object. Okay. So verifying the subject at the point of object. That means once a subject enters into object space, for example, I want to use the printer. At the printer, okay, before I use the printer, again it will verify at the point of object whether the subject is an authenticated user or not. Okay, so it is the second level of security. First level is identity management. Second level is authentication. So what do you mean by authentication? Authentication is nothing but verifying the subject, okay, identity at the point of object. Next one is called as authorization. So what do you mean by authorization? Authorization is nothing but, okay, if a subject, okay, which subject can access which resource. For example, if the subject is assistant manager, he can use only printer. If the subject is deputy manager, he can use printer as well as scanner. Okay. So if the subject is network administrator, he can use the entire object space. Okay. So that is called as authorization. So what do you mean by authorization? Authorization deals with which subject can access which resource. Okay. Last one is called as accountability. How do we maintain or how do we track the users using audit trails or logs? Okay. Why do we require accountability? Tracking the user from identity management, authentication and authorization. Okay. Now if at all you see how exactly an audit trail look like. Okay, so this is how an audit trail look like. Okay, so it will always store the data in an chronological order, date and time. Okay, so let us say at 19, okay, September 2020, username is ABC. He used a printer. He logged in at 10 o'clock. He used a printer up to 10:30 and he printed 100 pages. Whatever you do on the networks will be tracked using this particular audit trail. Okay. This audit trail is also called as log. Okay, so this is about, okay, access controls. Okay, how do we implement access control using identity management? So identity management, how many pillars we have? Three pillars: authentication, authorization and accountability. Next one, we have approaches to access controls. So how many approaches we have? Basically, we have three approaches. First one is called as RBAC. First one is called as RBAC. What do you mean by RBAC? Role-based access control. Second is called as REAC. So what do you mean by REAC? Rule-based access control. And third one is called as least user privilege control. Okay. So how many types of approaches we have? We have three approaches. First one is RBAC, second is REAC, and third one is least user privilege control. Okay. So what do you mean by RBAC? If rights and permissions are allocated based on the user role, it is called as RBAC. This I already told you, like teller can do debit and credit. Manager can do debit, credit, okay, or rectification of error. Okay, so branch manager can do debit, credit, rectification of error and opening of new account. So what exactly we are doing? We are assigning certain rights and permission based on the user role. Okay. Second is called as rule-based access control. Now what do you mean by rule-based access control? It will be having specific rules which will be allocated based on the role. Okay, so it will tell what can happen and what cannot happen. Okay, for example, let us say if at all assistant manager is applying leave, okay, the request will go to the deputy manager. Okay, now whether deputy manager can approve assistant manager leave? Yes, okay, it can happen. Okay, now whether a deputy manager can approve manager leave? No, it cannot happen. So this particular rule-based access control will tell, okay, what can happen and what cannot happen. Okay, so that is called as a rule-based access control. Next one is least user privilege control. So what do you mean by least user privilege control? It is nothing but only few privileges will be assigned based on the work profile. For example, if at all you are a backup manager, you can only install backup related softwares in your system. Okay, so that is called as a least user privilege control, which means as per your work profile, only that software, only the softwares relating to that particular work profile can be installed in your system. That is called as a least user privilege control. Okay. Next one, we have specialized information systems. I'm leaving this particular aspect. Okay, you have customer relationship management. So customer relationship management basically is required for the purpose of maintaining the relationship with the customer, to increase the brand value, resolve customer problems, etc. And supply chain management is required for the purpose of integrating all the departments together. Okay, so these two are called as specialized information systems. Okay, now after that we have a concept called as business intelligence softwares. Okay, so what do you mean by business intelligence softwares? So these particular softwares are required to analyze the data and to take business decisions. Okay, so actually we have 5. Okay, simple reporting and querying tool, business analytical tool, dashboard, scorecard, and data mining. Okay, so these are 5 business intelligence tools. Okay, now let me repeat again. So why do we require business intelligence softwares? On who will use these business intelligence softwares? These business intelligence softwares are used by top level management. Okay, so it is used by top level management. Okay, for what purpose? For the purpose of analyze, delete, set and go.